2 minutes. ఇది మినిమైజ్ అవ్వదా సార్? Okay. So hello everyone, very good afternoon and welcome to this live session hosted by Om Institute. Myself Gautam, founding member and also a faculty member at Om Institute, Hyderabad. So today morning GATE exam was conducted for ECE stream, and in this live session we shall discuss all the questions, almost all the questions, 95% of the questions that we could manage to get from our students in the next 2 hours or so. So once again, a very warm welcome to this session. So before we get started with the individual subjects, let me write down the weightage that has been in today's exam for each of the various subjects. Okay. So aptitude, so as usual we get 15 marks, 5 1-mark questions and 5 2-mark questions. See, aptitude paper, the questions from aptitude, they were not, at least 7 questions were very easy. Only 2-3 questions is where you need to slightly apply your mind. Okay. So this is routine fair, it is just 15 marks. Okay. Aptitude plus English. So aptitude plus English, it is 15 marks. I think from English we had around 3 questions, I suppose. Anyway, mathematics, again the questions were fairly straightforward. So anyone who has seriously prepared math would be able to get at least 10 marks and possibly all the 13 marks from mathematics. Okay. And in this session, our maths faculty will definitely come and discuss all the questions. Okay. So networks, all the questions were very easy. Yes. In fact, we had 2 1-mark questions and also 2 2-mark questions. Okay. So the overall weightage is going to be 6 marks. Okay. So from networks, 2 1-mark questions and also 2 2-mark questions. The total weightage for circuits or networks is what? 6 marks. Okay. So it is as if they have gifted you 6 marks. Okay. So signals, I think we had 2 1-mark questions and 4 2-mark questions, and the overall rating for the signals and systems questions would be easy to moderate. None of the questions were really difficult. So signals and systems, out of these 10 marks, any serious student should be able to score 7 to 8 marks in the worst case. Okay. So anyway, the weightage is what? 10 marks. So you can see for networks we have a relatively smaller weightage as compared to signals. Okay. So easy people, you need to focus more on signals, because networks, I believe the weightage, why it has gone down, because anyway the same networks will come up in analog circuits as well as in MOSFET circuit analysis. So they don't have to specifically focus on networks that much. Okay. So EDC, so among all the subjects in today's paper, EDC happens to be having the highest weightage. Okay. So again in EDC we had 4 1-mark questions and also 6 2-mark questions. Yes. So I was able to, I was going through the questions from EDC. So from EDC we have what? 4 plus 6 out of 12 questions, at least 10 questions are very straightforward. Only 2 questions is where you need to be conceptually very sound, and also you need to have that sense of aptitude. Okay. So EDC, the questions were very moderate level except for 2 questions. Okay. If you know that concept, you can do it, otherwise you just have to leave it. Okay. So the total weightage will be 16 marks, and surprisingly in EDC we did not find any questions from CMOS inverter or such related circuits. Okay. So analog circuits, the weightage is same as networks. So we had 2 1-mark questions and also 2 2-mark questions. So the total weightage will be 6 marks. So out of the 4 questions that we got from analog circuits, 3 questions are fairly straightforward. Only 1 question is where you really need to think on a serious note. Okay. Even that question, to me it sounds a bit controversial, okay, because there is some delay aspect that was mentioned in the options, and I could not make complete sense out of that delay thing. Anyway, we'll discuss that question in this session. So digital circuits. So this information I got from Hemant sir, that we had 3 1-mark questions and 4 2-mark questions, okay. This year, surprisingly, we have a slightly higher weightage for digital circuits, because usually the weightage for digital will be around 7 to 8 marks, not more than that, but this year it has reached 11, okay. So control systems, there were 2 1-mark questions and 3 2-mark questions. Sorry, 2 1-mark questions. Just a second. అది పెడతారా ఒకసారి? So we'll just wrap this up. So in control systems, we had 3 1-mark questions and 2 1-mark questions and 3 2-mark questions. So what I hear about control systems is that the questions are not difficult, but then a couple of questions were too lengthy, it seems, okay. So the total weightage for control systems is the standard figure, which is 8 marks, okay. And this year communication, we have a very high weightage. We had 4 1-mark questions and also 4 2-mark questions. So the total weightage is 12 marks. So after EDC, next highest weightage is for communications, okay. Again, communications, most of the questions are fairly straightforward, again except for 2 questions, it seems, okay. So last year EMT, the questions were completely out of the box. They were nowhere close to the general questions that are asked from EMTL, but this year luckily the questions were fairly straightforward from EMTL, okay. So I hear that there were no questions from waveguides and also from antennas. You only had questions from EM waves and transmission lines, okay. So EMT, we have 2 1-mark questions and also 3 2-mark questions, which means the weightage of EMT is 8 marks. So this is the overall weightage of the various subjects in today morning's ECE paper, okay. So if I have to give my opinion on this paper, I would say it is a typical GATE paper, what you would expect from IITs or the ISC, okay. It is a much better paper in terms of the standard of questions compared to last year, yes. So if you think last year paper was easy, then this year paper is not going to be easy. That much I can say with confidence, okay. So in this paper, there were a bunch of questions which are fairly easy, okay. If you know the subject well, easily you can do it. And from every subject, there were 1 or 2 questions which are really going to test your understanding of the subject. But in the exam, you have to be strategic. You have to solve as many questions as possible which are straightforward, and then you have to think about these few challenging questions, okay, because ultimately it's about maximizing the score. So I want to start with EDC, but before that our aptitude faculty will take over from me and quickly discuss and go through all the aptitude questions. Immediately I will get started with EDC. So I'll just hand it over to our aptitude faculty. Sir. తీసుకోండి.
Hello everyone, welcome to Gate Institute. Myself Amarnath Dimani, faculty for Aptitude, Pure Maths and Reasoning. As Sir said that, now I will continue with the Aptitude part of our Gate examination, ECE 2024, okay? Right, let us see the questions one by one. Right, see the first beautiful question, Gate ECE 2024, Aptitude part, first one. So coming to my part, Aptitude, I don't say that this is easy, I don't say that this is difficult. The paper is moderate only, not easy, not difficult, okay? So the first question, the greatest prime factor of 3 power 199 minus 3 power 196 is? So point 1, prime factor we want, okay, good. So all these numbers are prime numbers and the greatest one we want. So if you observe, in these two 3 power 196 I can take common, right? Because 3 power 199 I can write it as 3 power 196 into 3 cube, right? This is the important point because a power m into a power n is equal to a power m plus n, right? So now, why I am writing as 196 is here already we have 196. So 3 power 196 into 3 cube, that is 27 minus 3 power 196. Okay, now can I take 3 power 196 common? Yes, it is. Now it is 27 minus 1. Okay, if it is 27 minus 1, yeah, what I can say simply, so 27 minus 1 is 26, 3 power 196 into 26. Okay, now I want the factors and that too I need a prime number, right? Okay, so 3 power 196, okay, it has a 3, that is a prime number, happy. So in the options we have a 3, most of the students will go for 3, no that is not. Because 26 is nothing but 2 into 13, where 13 is a prime number, right? Okay, now we have to observe, so 13 is also there, this is the one, right? Now we have to decide 3 or 13. Sir, apart from 13, we have a number called 17. Okay, is 17 divisible also or also not? We have to check. Okay, so 3 power 199 power 3 and minus 3 power 196 is not divisible by 17. That is the reason the answer will be 13. So option is C is the answer. Okay, so as I said, now this is a mathematical point of view of this question. Or else you can go with the reminders concept of our topic called 3 power 199 minus 3 power 196. So greatest prime factor, it is a factor. Factor means when you divide with that number, the remainder should be 0, right? So we already know the concept of reminders there. So if I divide this one with 13, if I divide this one with 13, what is the reminders that we will get? So finally minus if I do, what is the final remainder? If it is 0, that is the answer, right? Like this also we can check, but compared to this one, whatever I have explained, that is the best one to do. Right, so the next beautiful question. Right. Yeah, this is a question that most of the students will suffocate and suffer. So as we know that the gate examination, in the examination we won't answer all the 100% questions, right? So we have to take the decisions wisely. So this question in the examination, if you leave it, that is the best one. But now I am explaining you, listen carefully. 4 identical chalk sticks, each of radius 0.5 centimeters and length 10 centimeters are bound tightly together using a duct tape as shown in the following figure. There are 4 chalks. Those 4 chalks were tightly bound, right? So that means that suppose assume this is a chalk and assume this is a chalk. Like that 4 chalks, so tightly bounded by the duct tape. Okay. Now we got this system, right? This system. Now what he is asking is the width of the duct tape is equal to the length of the chalk stick. Okay, means so these are the chalks, right? The chalks will go like this as a cylinders, right or wrong? Okay, this is another chalk. Okay, so then what happens automatically? This length of the chalk is nothing but the width of the duct tape. That is what he specified. Okay, fine. So next what he is asking is the area of the duct tape required to wrap the bundle of chalk stick once is. Bundle the chalk sticks only once. This is also very important. Okay, if he said twice, it will be different. If it is thrice, that will be different. Okay, right. Once we have to understand what we have to observe is. So now the one that we have to observe is zoom the image. Just zoom it. Okay, I am zooming to the maximum extent so that you can understand it better. Okay, right. Now observe this one. This is the image, right? This is the image. In this image, what I can say is, so this is the radius. This is the radius. Okay, that means chalk radius. This is the radius, radius, radius. Okay, now the point you have to notice is the duct tape will not touch the entire parts, but how it touches is, observe the diagram. So it will start touching like this. Okay, sir, how can I understand it? Means, so observe, I am drawing the chalk's cross section part here. Okay, that means the starting part. So chalk sticks will be like this, right? 4 chalk sticks will be like this. Okay. Now what happens? The duct tape will touch like this. Is it correct? Right. So the next beautiful question. 4 identical chalk sticks, each of radius 0.5 centimeters and length 10 centimeter, are bound tightly together using a duct tape as shown in the following figure. Okay, what he said is, there are 4 chalks. Suppose assume this is a chalk and assume this is a chalk. Like that 4 chalks he has taken like this, and he was just tied with duct tape. Fine. So then what we have to observe is how the shape look like is the important one. Of course, he has given a shape here, that from that if you can interpret, that is superb. Else I will show you the clear cut picture for it. Now the width of the duct tape is equal to the length of the chalk stick. The point you have to notice is the chalk sticks are like this, right or wrong? So this is the another chalk, another and so on, right? Then what happens? This is the length of the chalk, nothing but this is the width of the duct tape. That is what he specified clearly. Okay, fine. The area of the duct tape required to wrap the bundle of chalk stick once is, underline the word once. Okay, if he bundle twice, if he bundle thrice, all are different. Okay, don't worry, let us think of bundling only once, because that is what he is asking. Okay, what you have to observe is, so the tape look like this. Is it correct or wrong? Actually, if you observe in the stationery shops and so on, you will find a tape like this only, right? Like simply a newspaper or white paper. Okay, but the point you have to notice is, this we will roll, this we will roll. So when I roll it like this, this is the width. Okay, now what happens? So this is the circumference. If you know, then that is the end of the game, right? So this one, if you roll it, it will become like this. This will become the what we say cross section part of this one. This is the cross section part, right? That cross section is nothing but this is the one, this is the width. Means if this width is already known for me, because this is 10 centimeters he specified, because the width is nothing but length of the chalk stick, that is 10 centimeter. Now the only thing that I have to know is, this is the one, this is nothing but the perimeter of this cross section, right? Okay, now we have to calculate the perimeter of that cross section. That's why I'm just showing you clearly the picture of the cross section part. Okay, 4 chalks will be like this. Okay, 4 chalks, 1, 2, or else I'll draw a bit bigger one. 1, 2, don't ask me this much chalks are possible. Okay, 3, and this is the 4th one. Okay, 4 chalks are like this. Now you are wrapping it up, right? So for that, what happens? The wrapping will be like this. Is it correct? Okay. So it wraps up like this. Is it correct? Okay. Now the point you have to notice is, okay, some part it is mixing with the given chalks, right? Okay, some part only, not the entire part. Okay, so then what happens? I will divide it into small parts. Observe. Okay, this is the radius, this is the chalk, right? Radius. Okay, how much it is? 0.5, nothing but a radius. Okay, okay, now observe this, observe this. So if I study this part, the remaining part is okay for me. Right, the point you have to notice is, this is radius, this is radius. That means this is 2r, this is also 2r. Okay, fine. That is 2r. Okay, now this angle is 90 degrees, right? Here to here it is. Okay. Can I say it is a 1/4 circle circumference? Okay, this is the one, right? So this is actual full means 2 pi r is the circumference of a full circle, right? but this is only 1/4, right? Means 1/4 means by 4. So it is simply pi r by 2. Okay. So same to same, if you observe again, this is again equal to this 2r, right? Okay, 2r. And again this cross section part, this curvature part is equal to, as usual, like this, pi r by 2. And again this is equals to pi r by 2, right? Okay, pi r by 2, and this is as usual 2r, and this is as usual 2r, and this is pi r by 2. Okay, now this total is nothing but the width, right? Okay, so now I have to calculate this total. 2r, 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 total is 8r. So I know that 2r value is, r is 0.5 means 2r is 1. So 1, 1, 1, 1 means this straight line parts are 4 in length. Okay. Now this is pi r by 2, pi r by 2, pi r by 2, pi r by 2. So 4 into pi r by 2, right? Okay. How much you will get? 2 pi r. Okay. What's the value of 2r value? It's 1. So it is simply pi. So 4 plus pi is the cross section's perimeter. This is 4 plus pi. Now he is asking area of the duct tape. This is the area of the duct tape, right? So what I can say, area means length into breadth, right? Simply length into breadth means 10 into 4 plus pi. That's it. There ends the game. So which option is the answer? A is the answer. Okay. We can say that this is a beautiful question that he has given in the examination. Okay. Good. Because this is a combination that actually, coming to mensuration part, people will think of circle, circumference, area, etc., etc. Okay, so the other concept that we have to learn in 3D mensuration is, if you roll any what we say rectangle, you will get a cylinder, right? Okay, that cylinder sometimes, if the cross section is not circle, it will become a prism. Okay, this question is cross section to both. Okay, that is forming a prism from a rectangle, and this is circle from the circle combinations. Okay, this is an extraordinary question. Okay, we can say that this is a valuable question, we can say. Right, so the next beautiful question. Right, for a real number x greater than 1, okay, he is asking 1 by log x to the base 2 plus 1 by log x to the base 3 plus 1 by log x to the base 4 is equal to how much? Is equal to 1, and he is asking about the value of x. Right, only two logics that we have to apply here. Okay, point 1 we have to notice is log a to the base b is nothing but 1 by log. So if you write 1 by, these two will be interchanged. It will become log b to the base here. Okay, this is one rule we will apply. Second rule is log a into plus log b plus log c and so on, any number if you write. Okay, so what happens will, it will become log a into b into c into whatever he gives. This is the second rule. The third rule is log a to the base a will give you one value. These three rules, if you know, happily we can solve it in a like this manner. Okay, let us see the question for it. 1 by log x to the base 2 means it looks like 1 by log b to the base a. Means if you take to the numerator, the base and the value both will get interchanged. Means this we can write as log 2 to the base x. Fine. In between plus. This is also as is, I can write it as log 3 to the base x. And the next one is also as is log 4 to the base x. Superb. Okay, its value is specified as 1. Okay, fine. Now what I have to do is, so it looks like log a plus log b plus log c. Okay, means we can say that we can multiply all those numbers, right? Okay, that means we can write it as log 2 into 3 into 4. Okay, 2 3s are 6, 6 4s are 24 to the base x is equal to how much is specified? 1. And as I said earlier, log a to the base a is equal to 1, right? So you got 1, that means that these two should be same. So what's the value of x finally we got? 24. That's what he's asking. So it is how much? 24 is the answer. Okay. Right. So the next beautiful question. Right. So 5 years, this is a direct question from our notebook, we can say. Okay. Right. So 5 years ago, the ratio of Aman's age to his father's age was 1:4. Okay, so this is the present ages. Okay, 5 years ago means this is 5 years back. Okay, the ratio is how much? 1:4 he specified. Okay, and 5 years from now, the ratio will be 2:5. From now means from the present 5 years, the ratio is how much? 2:5. Okay, now he is asking what was his father's age when Aman was born. Okay, now the point we have to notice is, sir, here the difference is 3, here also the difference is 3, right? Okay, first we have to check this difference. Fortunately, the differences are same. If not, we will make it same, right or wrong? Okay, now, so here the age of Aman is 1 part, here it is 2 part. Means how many parts increased? 1 part increased. To increase 1 part, here 5 years, here 5 years, total 10 years time is required. Okay, that means that here the age of Aman is 1 part, nothing but 10 years. And here the age of his father is 4 parts, that is 40 years. And the question he is asking is the age of his father when Aman was born. When Aman was born. When Aman was born means questions. When Aman was born. When Aman was born means what we have to say? So simply 10 years ago, right? 10 years ago means father says already here 40. 10 years ago means his age will be 30. So answer is A. What's the answer? A is the answer. Okay. Right. Just a second. We will go for the remaining questions one by one. Okay. We'll go to the remaining questions one by one. Right. The next question that we have to understand is get right. This is the next question that we have to understand. Yeah, this is a beautiful question that we have to notice. Okay, actually you have to you just need to understand the question. If you understand, it is okay. Okay, right. The question is two identical sheets A and B of dimensions 24 centimeters by 16 centimeters can be folded into half using two distinct operations FO1 and FO2. Those two are the operations. Okay, right. What we have to observe is the axis of folding remains parallel to the initial. Okay, in FO1, the axis of folding remains parallel to the initial long edge. Folding is parallel to the initial long edge. Okay, now let us draw an image here. Okay, fine. Okay, assume. Yeah, assume this is my right. Just a second, I will fill it. Okay, good. This is my paper. Okay. Now the dimensions of the paper is 24 and this is 16. So in FO1, what he said, the axis of folding remains parallel. Means I am folding. When I am folding, definitely there will be some axis, right? Suppose if I fold like this, okay, this vertical is the axis. If I fold like this, then this horizontal is the folding, right or wrong? Okay, definitely there will be some axis, right or wrong? Okay, now what he said is the axis of folding remains parallel to the initial long edge. Okay, so initial long edge means this is the long edge, right? Okay, parallel to this he folded. Parallel to this means he folded like this. Okay, into two halves, right? Here he specified that folded into half. Okay, means this will become 8, this will become 8. So this is nothing but the FO1. Okay. Now what happens about FO2? Okay, let's see here. In FO2, the axis of folding remains parallel to the initial short edge. Initial short edge. Let us draw it. Okay, now I'm drawing. My God. Yeah, good. So now I'm drawing another paper like this, similar one. Okay, now I have to fill it with the one, right? Okay, filled it. Now the dimensions are 24 and 16. Now I'm going to FO2. In FO2, he specified that clearly the folding will be parallel to shorter edge. This is the shorter edge, right? Okay, like this he folded. Means this will become 12 and 12. The most important point that you have to notice is, okay, the foldings will be made not based on the present ones, based on the initial long edge and based on the initial short edge. Okay, if sheet A is folded twice using FO1, okay, suppose this is sheet A because this is FO1, right? Folded twice, okay, and sheet B is folded twice using FO2. This is paper B. The ratio of the perimeters of the final shapes of A and B is, okay, it was folded 2 times. Okay, this is folding 1, right? Okay, after the folding this is 24 and this is 8. Superb. One fold is completed. Second fold. Second fold means again I have to fold parallel to the length of the longer edge. Longer edge means from this part or from the initial long edge. Initial long edge. Initial is this is the one means, okay, this time again the folding will be like this. And this is 4 and this is 24 as usual. This is 4 and this is 24, right? Now, what is the perimeter? Okay, so this is a rectangle, right? 2 into L plus B. So 2 into 4 plus 24. Okay, good. So this is first ones. Let's go to the second one. This is also folded twice, right? Now this is 12 and this is 16. People will think that, sir, it will be folded one more time. So based on the short edge, they will think. Now this is the short edge. So they will think that this is the folding. No, 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 no. He clearly specified that initial short edge. This is not the initial part, right? So it will not be folded here only. Okay. So it will be folded again 16 and with the 16 I have folded, right? Now also parallel to this one, like this only it will be folded. Okay, now this is 12, right? Now it will become half. It is 6, it is 16, it is 6, it is 16, right? Okay, now the perimeter means 2 into L plus B, right? 2 into 16 plus 6. Okay, superb. Now he is asking about the ratio of it. Okay, ratio means that is 24 plus 4 is 28 into 2. 28 into 2 is 2. This is 16 plus 6 is 22 into 2. Fine. Into 2 cancels. 2 11s and 2 14s. So answer is 14 is to 11. So answer is D is the answer. Okay, because we have to give from A to B, not from B to A. Okay, so that's why we have to go with 14 is to 11, not 11 is to 14. Okay, right. So the next beautiful question. Right, this is the next one. It's actually, we can say that a common sense question, we can say simply. Okay, see that PQRS and T has launched a new startup. Okay, so 5 members, who they are? P, Q, R, S, T. These 5 members, okay, launched a new startup. Okay, 2 of them are siblings. Okay, out of these 5, 2 members are siblings. I don't know who they are. Okay, the next point he said is, the office of the startup has just 3 rooms. Okay, that office has only 3 rooms. Okay, 3 cabins we can imagine. Fine. All of them agree that the siblings should not share the same room. Okay, there are 2 siblings, right? Those 2 should not be in the same room. Okay, fine. See, actually 3 rooms means, okay, 1, 2, 3 rooms. Okay, 2, 2, 2 means 6 members. 1, 1, 1 members, only 3 members. But we have 5. That means that 2, 2, 2, 2, 2 and 1. Totally we will get 5, right? Okay, so only 1 room will have 1 person, right or wrong? Okay, fine. So now what we can say is, if S and Q are single children means, suppose I am the only son or only child to my father or mother, then I can say that I don't have any sibling, right or wrong? That's what indirectly he is saying. If S and Q are single children means they don't have any siblings. They don't have any siblings, means these 2 can share the room. Am I right? Okay, keep it aside. And the room allocations shown below are acceptable to all. Here 2 allocations I am showing. This is acceptable to all. This is also acceptable to all. Now the question he is asking is, then which one of the given option is the siblings? Okay, which one of the given options? So what we can say, out of 5 members, my question is on siblings. I can say that S and Q are single children. So those 2 will not be. Now I have to think that, okay, these 2 are not siblings. Suppose if P is also not, then R and T are siblings. If R is also not, then P and T are siblings. If T is also not, P and R are siblings. Means I have to identify one more person who is not a sibling. Okay, see the first one, he said that P, R are sharing a room. That means that I can say that P and R are not siblings. P and R are not siblings. Okay, T and S are sharing, and of course S is already a different one, so I don't need to think of it. Leave it. So the next one is saying P, Q are siblings. Sir, Q, okay, not siblings. That already I know that. R and T are not siblings. So these 2 are not siblings. Observe that. Either PR should be siblings. Either RT should be siblings. Or PT should be siblings. That is what the data that I know, because these 2 are not siblings. But there is a sibling, right? But now we came to know that P and R are residing in a room means these 2 are not siblings. Here R and T are residing in a room means these 2 are not siblings. Means ultimately who can be the siblings? Only P and T has the possibility to become the siblings. Who? P and T. So which option is the answer? A is the answer. Okay. Right. Like this we have to analyze. This is a common sense question. Never feel that this comes under so and so topic or not. Okay. Good. So the next beautiful question. Right. Yeah, this is a regular question that we can expect. Okay. And what he said is, examples of mirror and water reflections are shown in the figures below. So reflections. So this is mirror reflection and this is water reflection. And of course, even though he has not given, we know that in mirror reflection, left and right interchanges, top and bottom will not, top and bottom. Whereas in water reflection, top and bottom interchanges, left and right will not. Alright? Okay, these two are shown here. An object appears as following image after first reflecting in mirror and then reflecting in an water. The original object is. The original object is. So the one that he has given is not the original one. This is the one after reflecting in mirror, then you will get one product, right? That one with water. Okay. So means suppose if it is the original, okay. So first we have gone with mirror, then we have gone with water. Okay. So now this is what he gave. Now we have to roll back, means water image reflection we have to nullify, then mirror image reflection we have to nullify. What I know very well is mirror of mirror is nothing but original. Always remember that. Mirror of mirror is nothing but original. Same to same, water of water is also nothing but original. Water of water is also nothing but original. Okay, good. This is nothing but original. Okay. Is equals to original. Now what I can say is, sir, this is mirror image. This is what he gave, right? Now I have to remove the mirror. Means I have to go with the reverse of mirror, reverse of water. Nothing but again water image. So what I have to do is water image followed by mirror image I have to do. What I have to do? Water image, then mirror image. Okay. Good. Water image, nothing but it's water image. Top and bottom interchanges. This line, bottom, top, right, bottom, top, this is. Okay. Same to same, dot. Okay. 2. Okay. Vertical line, bottom, top, and so on. This is 4 vertical line. Okay, right side. Okay, this is the one. Okay, water image completed. Means water was nullified. Now I have to nullify the mirror. If I want to nullify the mirror reflection, what I have to do? Mirror of mirror only nullifies the mirror, right? It will become original, right? Now I have to go for the mirroring part for it. Mirroring means what happens? Left and right interchanges. This is the rightmost one. Now it will become the leftmost one. Okay, left side you got it. Now you have to write it on the right side. Okay. Now 5, you started going to the left side. Now I have to go for the, so you are going to the left side, right? Now I have to go for the right side. Okay, good. This is completed. Now I have to go for the dot. Dot will be dot only, no problem. So now this 2, you started from left to right. Now I have to go for right to left. Right to left means this is the one, right? So this will be the original image. This will be the original image. Hope you understand. Thank you, my dear boys and girls. So this is the aptitude part. Hope you understand. Some questions are direct from the classes. Some are not direct. Okay. Especially the chalk question is a new one for you, and it's a beautiful question to learn. And even if you observe, the paper folding is also very funny question to do. Okay. You have to means your readability and understandability were checked here. And even this one also a simple question, right? A common sense question. Okay. This is the paper. Thank you. Myself, Amarnath Dimani, signing off. Jai Hind.
Start? Okay. So, okay guys, welcome back. Sorry for the interruption. We had a power outage. So, we just had a discussion on aptitude. Now, we will get started with EDC. So, as I said in the very beginning, so from EDC, we had 4 1-mark questions and I think 6 2-mark questions. So, first I will go through all the 1-mark questions, then we will move on to the 2-mark questions. Okay. So, the first question goes something like this. So, I will briefly describe the question. I hope you can get the context. Okay. So, what is given? There is a non-degenerately doped n-type silicon sample or some n-type semiconductor. Okay. So, we have what? Non-degenerately doped n-type semiconductor. So, non-degenerately doped, it means what? It is not too heavily doped. Okay. It is the usual semiconductor where the doping level is what? Low to moderate. It is not too heavy. And in this non-degenerately doped n-type semiconductor, you have to plot log n, where n is what? The free electron concentration. In fact, it is what? The majority carrier concentration versus 1 by T. That is what? The plot between logarithm of the electron concentration and the inverse of the temperature. So, 4 different plots were given and you have to choose the correct plot. Okay. So, it is completely based on this particular plot. So, generally for an n-type semiconductor, this is how the free electron concentration varies with temperature. So, what is it? At very low temperatures, you do not have generation of EHPs, thermal generation of EHPs, and also the degree of ionization will be really low. So, at low temperatures, there is no generation, there is no ionization of donors. So, n will obviously start from 0. You know, at 0 Kelvin, n is what? 0. And slowly as temperature increases, the donors start getting ionized. So, more and more donors will get ionized. N will continuously increase with temperature. Now, at some point when you reach a certain temperature, which is somewhere around 150 to 200 Kelvin, all the donors would have gotten ionized. All the donors would have gotten ionized. So, initially your electron concentration will increase with temperature. Let us say at this particular temperature T1, you achieve the so-called complete or 100% ionization. Now, beyond this temperature, there are no more donors that are left to be ionized. All the donors that we have added will become ionized. So, there will be no further increase in the value of n. So, for some time or for some range of temperatures from now, the value of n would remain constant. Okay. By the way, this is what? Constant. Okay. Now, when you approach very high temperatures, you know, at high temperatures, we are going to have very high rate of thermal generation of EHPs. So, Ni will become too large. Yes, at high temperatures, whatever carriers you get through thermal generation, that is what? Ni, that can actually become far greater than Nd. Yes, at moderate temperatures, especially around the room temperature, our Nd will be far greater than Ni. So, the material will have extrinsic nature. But when you go to very high temperatures, Ni will become so large that it will be much bigger than Nd. And the material or the semiconductor, it starts to become intrinsic. So, once it becomes intrinsic, your N will approach what? Ni, and you know Ni will exponentially increase with temperature. Ni proportional to what? E power minus Eg by 2 kT and also T power 3 by 2. Yes, sir? Yes. So, this is proportional to T power 3 by 2 times exponential minus Eg by 2 kT. Yes. So let's say at this particular temperature, the Ni will start dominating over Nd, and because Ni increases with temperature, N also will increase with temperature. This is the typical plot between the free electron concentration and temperature. But what is asked in the question, you have to plot logarithm of this N versus 1 by T. Remember, T and 1 by T are obviously inverse of each other. So what kind of plot we must expect? So log N versus 1 by T. You see, if 1 by T is what, very small. When will 1 by T be very small? When T is what, very high. Yes. So here we actually have what? The high temperature zone or high temperature region. High temperature region, yes, N will, the material becomes what? Intrinsic. N will increase with temperature. If N increases with temperature, then if temperature is increasing, 1 by T will decrease, but log N will increase. Okay. So as you go towards the left, 1 by T is what? Decreasing, which means what? You are going to higher and higher temperatures, your log N will increase. Yes. And then in the middle, that is what? This range, because N is what? Constant. N is what? Constant. In fact, this level, you can say it is what? Nd. Okay. So at this level, in this range between T1 and T2, N is what? More or less constant. So here also in this range, N will remain constant. Okay. And then let's say you are going in this direction. If you are going towards right, it means what? 1 by T is what? Increasing. When will 1 by T increase? When T is what? Decreasing. So you are going towards what? Low temperatures. You are going towards low temperatures. So when you go to low temperatures, the degree of ionization will start falling. So when you go to 0 Kelvin, 1 by T will be what? Enormously high, and at 0 Kelvin, N will drop to what? 0. Okay. So basically you will have something of this sort. So among the 4 options, this is the only option that makes real sense. Okay. The other options, they don't make that much sense. So if you have chosen this option, then it is the right answer. Okay. So this is the first 1 mark question. So quickly we'll look at the next 1 mark question. Sorry. In this question, it goes like this. Some transistor circuit is given, and this happens to be an NMOS transistor. And around this transistor, a couple of capacitors were connected. So one such capacitor is what? C1, which is connected between gate and source, and another capacitor is connected between source and ground, and that is called as C2. Okay. And then let this be VDD, which will anyway become 0 or AC ground during AC analysis. It is already given that for the transistor, the small signal parameter is what? GM. And also for the transistor, there is no channel length modulation. No channel length modulation, it means what? Lambda is 0, R0 is infinite, and that there is also no body effect. So for the transistor, there is no body effect, which means the source is what? Short to body, etc. Okay. And then the question is what? This. So if you are looking into this network in this direction, what is the equivalent impedance that you are going to see? So the question is what? To find Zin of j omega, okay, which is like the input impedance. Okay. So all you have to do is what? Draw the small signal equivalent circuit, and then because you are required to find the input impedance looking between this point and ground, after drawing the AC or the small signal equivalent circuit between this point and ground, you just have to connect that voltage source VT, test voltage source, and find the ratio of VT to IT. It's a very trivial problem. Okay. So let me quickly draw the small signal equivalent circuit. First, let us replace the transistor with its equivalent circuit. I think also in the question it was given that you can ignore the internal capacitances of the transistor, because remember, within the transistor you have CGS, CGD. You can ignore all those internal capacitances, meaning what? All those capacitors will tend to behave like open circuits. Okay. Anyway, so what are we going to get in place of the transistor? The same thing which we usually draw between gate and source. We have what? An open circuit, and the drop across this open circuit is what? VGS. And then from drain to source, you have this voltage control current source, which is GM VGS, and at the top, this VED, like I said earlier, will become AC ground. And then you connect the two capacitors. Okay. So one capacitor is connected between gate and source, which is what? C1. So repeat the connection here. Sorry, C1. And between source and ground, we have another capacitor, which is C2. And then to find the input impedance looking in this direction, between this point and ground, you must apply this voltage source VT. Let the current flowing out of the plus terminal be IT. This is a standard procedure to find the input impedance seen looking in any direction into any network. Okay. So from here on, it is quite simple. What is this current? It is 0. So this entire IT will only flow through what? C1. So what is this current? It is what? IT. So what is resulting drop across C1? It is IT times the impedance of C1, which is IT by S C1. In fact, the C1 is connected between what? Gate and source. Even VGS is what? The drop between gate and source. So directly I can say our VGS is same as what? The drop across C1, which is IT upon S C1. Okay. And then this current is again what? IT. And what is this current? It is same as this current, which is GM VGS. Okay. So what is the current through C2? Now at this node, two currents are entering, this current is what? Leaving. So sum of these two currents will be equal to what? The current through C2. So this current will be what? IT by S C1 plus GM VGS, and VGS, just now we wrote it. Sorry, this current is actually IT. I'm sorry. So from the left, what is the current entering? It is what? IT. And from the top, what is the current entering? It is GM VGS. VGS is what? This. So plus GM times IT by S C1. That's all. Once you know the current through C2, you can easily write the drop across C2. Just multiply the current with the impedance, and then all you have to do is what? Just write KVL around this loop, because this is ground, this is also ground. You have to understand that we have a closed loop, and around this loop we can write what? KVL. Okay. Anyway, so what is that KVL equation going to be? Okay. So VT, which is what? The applied voltage, is equal to what? Sum of these two drops. Drop across C1 plus the drop across C2. What is the drop across C1? IT by SC1. What is the drop across C2? Again, the current through C2 is what? This, multiplied with the impedance of C2, which is 1 by SC2. And this is going to be what? IT upon SC2 plus GM IT by SC1 into 1 by SC2. See, 1 by SC1 into 1 by SC2 is going to be what? S square C1 C2. So GM IT upon S square C1 C2. That's all. So on the left hand side, you just have VT. On the right hand side, we have what? Three terms. All three terms contain what? IT. Pull out IT. Then VT by IT is going to be what? The final answer. That is what? Zn Okay. So right now we have Zn as a function of S. So in the end, all you have to do is what? Substitute S equal to j omega. Okay. So when you do that, you will get 1 by j omega c1 plus 1 by j omega c2. S square is what? Minus omega square. So last term is going to be negative. So minus 1 by omega square c1 c2. So I am sure this is one of the options. So if you have chosen this option, then yes, you have done a good job. Okay. So it is not complicated. You just have to draw the small signal equivalent circuit and find Vt by It. Let's move on. So we'll just look at the next 1 mark question. Actually, this is what MSQ, which means there can be multiple correct options. Okay. So in this question, basically the electron concentration profile is given. That is how the value of n varies with distance within some semiconductor. It is also given that the semiconductor is at equilibrium. Yes, there is a semiconductor which is at what state? Which is at equilibrium. So you have to clearly understand the meaning of equilibrium. At equilibrium, in any system or in any device or in any semiconductor, there is no net movement of carriers, or I can say there is no net movement of free electrons. There is also no net movement of holes. Mathematically, I can describe this as what? The net electron current density at equilibrium is what? 0. The net hole current density at equilibrium is also what? 0. Now, what is the given plot? It is the variation of n with respect to x, and the variation goes something like this. So this, sorry. So one end of the semiconductor is what? Located at A, and near the middle the location is what? B, and towards the right end the location is what? Labeled C. So this is the electron concentration profile. So clearly it is what? Non-uniform. Had it been uniform, then it should have been a straight line which is purely flat or horizontal. But here there is a gradient. Whenever there is a gradient, immediately diffusion will take place. Okay. And 4 options are given, or 4 statements are given. You have to choose all the correct statements. Okay. So I'm sorry I don't have the options typed right now. I just roughly have the options. I'll write it for you. Then we'll pick the correct statements. Okay. So the first statement goes something like this, that between B and A, J and drift, meaning electron drift current is from B to A. This is one statement. Another statement is what? Like this, between B and C, the electric field is directed from B to A. And then between B and A, again it is given that the electric field is directed from A to B. And then the fourth statement, that is option D, is what? Between B and C, it is given that the electron diffusion current, I'll simply write it as Jn diff, is in this direction, that is from C to B. So these are 4 simple statements given about this particular plot. Which plot? The electron concentration profile. Let us pick the correct option. Okay. As I already said, at equilibrium, there is no net flow of free electrons and also no net flow of holes. Here, we don't have to worry about holes, we will only worry about free electrons. So, whenever there is a concentration gradient, immediately there will be what? Diffusion of carriers. So, in this case, electrons will diffuse from high concentration to low concentration in any case, okay. So, electrons will diffuse from B towards A. At the same time, electrons also will diffuse from B towards C. Yes, B to A and also B to C. So, because of this diffusion, there will be what? A diffusion current. There will be what? A diffusion current. Always electrons will diffuse in one direction and the resulting diffusion current will be in the opposite direction, okay. So, this is going to be Jn diff, this is going to be Jn diff. Now, at equilibrium, the net electron current density has to be 0. At equilibrium, the net electron current density has to be 0. What is the meaning of net electron current density? It is the algebraic sum of the electron diffusion current and the electron drift current. So, just write it. At equilibrium, Jn is what? 0, which means Jn drift plus Jn diff, it is what? 0. So, already due to the concentration gradient, we have what? Diffusion. Now, an electric field will be built in or created within the system, which will result in what? A drift current, and that drift current will cancel out this existing diffusion current. Only then the net current will become what? 0. So, now to cancel out this particular Jn diff, you should have Jn drift in the opposite direction. Yes. So, this is what? The direction of Jn drift. This is between A and B. And when it comes to this region between B and C, already we have a diffusion current flowing from C to B, and to cancel this out, you must have what? Sorry, you must have drift current of equal magnitude but in opposite direction. And remember, the drift current is always in the direction of electric field, be it electron drift current or hole drift current. Drift current is always in the direction of the electric field, okay. So, for this drift current, the electric field must be in this direction, and for this drift current, the electric field must be in this direction. So, this is pretty much the complete insight that we can get from the given plot. Now, from this insight, let us try to pick all the possible correct options, okay. Read the first option between B and A, that is what? Left hand side, Jn drift is from B to A. Look at this, Jn drift, it is from B to A. So, option A, indeed it is correct. Option B, between B and C, that is in this region, the electric field is directed from B to A. Look at the electric field. Oh, sorry. Electric field is directed from B to C. That is the actual correct option that is given. So, between B and C, what is the direction of electric field? B to C, that is exactly what is given. So, B is also correct. And look at option C, between B and A. Between B and A, it is given that the electric field is from A to B, but between B and A or between A and B, look at the electric field, it is from B to A, whereas it is given that it is from A to B. So, this option is what? Incorrect. And then between B and C, Jn diff is going to flow from C to B. So, between B and C, already we have the direction of Jn diff, it is flowing from C to B, which is correct. So, what are the three correct statements? A, B and D. All right. So, let us move on. There is one more question. And the circuit is made up of both NMOS and PMOS transistors. In fact, this is what? The classic CMOS differential pair. Yes. So, tomorrow when you get into analog design, this circuit is going to be the bread and butter of analog circuit design. Okay. So at the top we have these two PMOS transistors which actually form what a current mirror. Okay. And at the bottom we have the two NMOS transistors which are the two input transistors. Okay. And at the gate of this transistor the input is applied, which is some Vn, and at the bottom we have a tail current source which is meant for biasing the transistors in the saturation region with the appropriate overdrive voltage, etc. Okay. So let this current source be some ISS, and then what is given, this connection is made. Okay. They have made this connection and they are saying that at this point they are going to take the output. I think there was a lengthy description about this question, but to cut it short, the basic funda is what this. They have given that the open loop gain, it is what 40, and you have been asked to find the value of the closed loop gain. Yes. So you might think nothing else is given, no GM is given, no R0 is given. How do you do the analysis and find ACL? That's why you have to think before you start answering. So first you must identify that AOL, that means what? Open loop gain, which is the gain without feedback. So first of all, what is the amplifier going to be without feedback? And ACL is what? Closed loop gain, which is the gain after adding feedback, after incorporating feedback into the circuit. So where is feedback here in this circuit? The feedback in this circuit is due to this connection. The feedback in this circuit is due to what? This connection. Okay. So if you take out this connection, then it becomes what? The open loop case. Then it becomes what? The open loop case. Okay. So let me just draw the open loop amplifier. So the open loop amplifier is what? The same circuit without this connection. So what is this connection here? This point is shorted to what? This gate. This point is what? Shorted to this gate. So if you take out this small connection, the resulting amplifier is what? The open loop amplifier. Okay. And that open loop amplifier so this is your typical CMOS differential pair. So if you have a classic two-stage op-amp, in that two-stage op-amp, this is going to the first stage. Okay, CMOS differential pair. Is it resistive load or active load? It is active load, because normally for a differential amplifier, you would expect to have resistors connected at the top, at the drain of this NMOS and also at the drain of NMOS. But when you have resistors, you don't get enough gain, and you're also going to waste a lot of gain, especially when you take the output at only one point, not differentially but in a single-ended manner. So now to overcome those problems, we simply take out the resistors, and in that place we put this active load, which is formed by the PMOS current mirror. Okay. So for this CMOS differential pair, any differential pair will do what? It will have two inputs, V1 and V2, and the output will be proportional to what? The difference between the two inputs, that is V1 minus V2. So if this is V1, if this is V2, your output will be what? A times V1 minus V2. This is what is a differential amplifier. Is it not similar to op-amp? Even op-amp has got two input terminals, and the output is equal to what? A times V plus minus V minus. So here the important point to understand is what? This circuit, you should think of it as an op-amp. You should think of it as what? An op-amp. Okay. Now what is the gain from here to here? It is what? Positive. What is the gain from here to here? It is what? Negative. Okay. So this is like the plus input terminal of the op-amp, and this is like the minus input terminal of the op-amp, and whatever open loop gain is given, it is actually what this A. I hope you have understood this. Okay. So what we have here is a CMOS differential pair whose gain is what 40, and then to this differential pair we add this connection. Okay. Now the way to simplify this circuit is what, like this. So instead of drawing the CMOS differential pair, you just draw an op amp, because I told you what this will act as what, an op amp. In fact, this is what a single stage op amp. This is what a single stage op amp. Okay. So you have a single stage op amp with a gain of 40. Yes. And what is done in the given circuit, the output is shorted to what, this terminal, and this terminal is what, the minus terminal. Okay. So here also the output is shorted to what, the minus terminal, and this is what V0. And where is the input applied? At the gate of this transistor, and the gate of this transistor is what, the plus terminal of the differential pair. Okay. Have you not seen this circuit when you studied analog circuits? This is what, the classic voltage buffer. So when you think of a voltage buffer, what should come to your mind? Voltage buffer, input is applied at the plus terminal, and then the output is simply shorted to the minus terminal. And if the op amp is ideal, then V0 by Vi is what, simply, this is V0. In the ideal case, the closed loop gain is what, 1. So here, since the output is what, directly shorted to the input terminal, what is the feedback factor? It is what, 1. Feedback factor is what, 1. So what is the open loop gain? It is 40. What is the feedback factor? It is 1. So from here, can't we directly write the expression for the closed loop gain? ACL equal to what? AOL upon 1 plus AOL times the feedback factor, which is BR, beta. Now what is the open loop gain? It is 40 upon 1 plus 40, which is 40 by 41. 40 by 41 will be what? 0.9, 0.97, 0.98 something. Okay. And I hope this is one of the options. So what is the given circuit? It is a simple voltage follower. So using the transistors, they made an op amp, a simple single stage op amp, and then the output is directly connected to the minus input terminal. Okay. So the resulting circuit is what? A voltage follower. Voltage follower is also what? Voltage buffer, whose gain is what? Very close to 1, ideally 1, but very close to 1. Even our closed loop gain, you can say, is what? 0.97 or 0.98 something, which is quite close to 1. So these are all the 1 mark questions from EDC. So now we'll move on to the 2 mark questions from EDC. Okay. Oh, sorry. So Q6. So there is also what, an MSQ, and it is what, a 2 mark question. So in this question, 4 different statements are made regarding the current gain, that is what, beta of a transistor, that is BJT. Okay. 4 statements regarding beta of a BJT. So the first statement goes something like this. I think in the first statement it is given that beta, that is the current gain in saturation, is generally less than the current gain in active. Is it not true? In fact, this is what the condition for a BJT to be in saturation. Beta sat must be less than beta active. Okay. This is actually correct. And the next statement is what? Under high level injection. So first of all, what is this injection? What is the transistor action? The base emitter junction is what? Forward biased, and because of this, carriers are injected from emitter to base, which will diffuse through the base, and eventually they'll reach what? The collector. This is the transistor action. So if a if a very large number of carriers are injected from emitter to base, that is the case when we have high level injection. So under high level injection, it is given that as IC increases at high level injection, as the collector current increases, they are saying that the current gain will decrease, beta will drop. That is the B option. This is actually correct. And C option goes something like this. Under low level injection, as IC increases, they are saying what? Beta will, as IC increases, beta will decrease. Actually, this is incorrect, okay, because when I draw the plot, you will understand, okay. And the D option is what? That a higher current gain leads to a smaller VCE breakdown voltage. So these are the four options. Let us pick the correct statements, okay. So the first statement already I said it is what? Correct. See, the plot between beta and IC is generally like this. So for a BJT, the beta versus IC plot is what? Like this. So when IC is what? Really small, we have the low injection regime, and when IC is really high, we have the high level injection regime, okay. So this is what? Low level injection regime, and this is what? The high level injection regime. So what is happening at high level injection condition? As IC is increasing, you can see beta is what? Decreasing. High level injection, IC increases, beta is what? Decreasing. So both A and B are actually correct. Under low level injection, as IC increases, beta is what? Increasing, but here it is given that beta is decreasing. So I think option C is what? Incorrect. And then if you look at option D, higher beta leads to a smaller VCE breakdown voltage, okay. So if beta is increased, then the breakdown voltage between collector and emitter, they are saying it will decrease. Let's find out if it is true or not. So if you take a typical transistor, VCE, so NPN. So this is what? The emitter. So at the bottom we have what? Emitter, and at the top we have what? Collector, and then we are going to apply some voltage VCE, okay. See, when we apply this voltage VCE, see, in the transistor there are two junctions, okay. One is what? The base emitter junction, which is this, and this is what? The base collector junction. Now due to this positive VCE that is applied across the transistor, what will happen to the two junctions, okay. So this is what? The base emitter junction, this is what? The base collector junction. So because VCE is what? Positive and quite large, I think this will be forward biased, and the other junction will be what? Reverse biased, okay. And then because the base emitter junction is what? Forward biased, there will be injection of carriers across the base emitter junction. A lot of electrons will be injected from emitter into the base. So these are what? Electrons injected from emitter into the base. Now remember, the base collector junction, base is what? Lightly doped, collector is also what? Lightly doped. So what is the kind of breakdown that might occur for the base collector junction? Yes, if you keep on increasing VCE, forward bias junction, the voltage drop saturates to what? V on, that is like 0.7. So whatever extra voltage that you have beyond 0.7, all of that voltage will only appear across what? The base collector junction as some reverse voltage. So as you are increasing VCE, in a way you are increasing what? The reverse voltage of the base collector junction. Okay. So here what kind of breakdown? You will have what? Avalanche breakdown. You have what? Avalanche breakdown. Yes. Now if beta increases, alpha also will increase. Alpha also will increase. Then more number of carriers that are injected from emitter into base can participate in this avalanche breakdown process. So if you have more number of carriers participating in the avalanche breakdown process, then the breakdown can occur at a relatively smaller voltage. Yes. So VCE BD is what? Like breakdown voltage of the transistor between collector and emitter, it will decrease. I think this is what is given in the D statement. Higher beta leads to what? A smaller VCE breakdown voltage. I think this is correct. Yes. So the correct options are what? A, B and D. All right. Let's move on to the next question. Some circuit is given, and for this circuit you have been asked to find the magnitude of the small signal voltage gain. Okay, and circuit goes like this. So this is what transistor M1, this is what transistor M2, and for M1 the small signal parameter is what? GM1, and for M2 it is what? GM2. And the question is what? To find the magnitude of the small signal voltage gain, that is what? Mod of V0 by Vn. Okay. So already for the transistors, the small signal parameters are given. So you don't have to do the DC analysis. You can directly jump to what? AC analysis. I think in the question it is also given that during AC analysis you should treat C1 as a short circuit. You have been asked to treat C1. What is C1? It is some type of coupling capacitor, and generally it is what? Short during AC analysis. Okay. You see, you don't have to draw the complete small signal equivalent circuit. First of all, if you look at this transistor, is it not in common source configuration? Because some input is going to be applied here. I mean, the actual input is what being applied here, but a fraction of it will appear at the gate, and then you are taking what? Output at the drain. Input applied at the gate, output being taken at the drain. It is what? The common source amplifier. And also there is no channel length modulation, etc. So no channel length modulation, it means what? R0 tends to infinity. Yes. So for example, if I call the voltage at this point is what? Some Vx. Now this Vx is what? The input for this common source amplifier. I am only talking about this part of the circuit. Now what is the gain of this common source amplifier? V0 by Vx, and it is what? Minus Gm2 times the net resistance at the drain. After all, the source is what? Connected to ground. Okay. So what is V0 by Vx? V0 by Vx is what? Gain of this common source amplifier, which is minus Gm2 times Rd. So the question is what? To find V0 by Vn. So now you have to find Vx in terms of Vn. Now during AC analysis, any DC source will become 0. So this becomes what? Open. Now if you look at this particular transistor, is it not a diode connected transistor? Because clearly the drain is what? Shorted to gate. Any transistor whose drain is shorted to gate during AC analysis will behave like a resistor of value 1 by Gm parallel R0. But here there is no R0. So it is simply going to behave like a resistance of value 1 by Gm1. And that 1 by Gm1 is going to be connected between this point and ground. And this becomes what? Open, which means Rb and this 1 by Gm1 resistor will be in series. Yes. And remember, this current is what? 0. Now this Rs, Rb and 1 by Gm1, do they not form a voltage divider? So I can only draw this part of the circuit separately. Okay. So first we have what? Vn followed by Rs followed by the capacitor, which behaves like what? A short circuit. And then you have this node Vx. And after Vx, we have a series combination of two resistors, Rb and this equivalent resistance 1 by Gm1. So I can write this as Rb plus 1 by Gm1, sorry. And this is what? Vx. So now you just have to apply voltage division. So Vx by Vn is what? Rb plus 1 by Gm1 upon Rb plus Rs plus 1 by Gm1. So already we have V0 by Vx, now we have Vx by Vn. Now when you multiply this and this, directly you will get V0 by Vn. Again, please understand that because I am explaining, I am taking this much time. Otherwise, one should be able to solve this in under a minute, not more than a minute. Okay. So anyway, V0 by Vn is what? Product of this and this. And when you do that, you will get what? This thing into Gm2 Rd. And the question is what? I think to find the gain magnitude. So I'll just write the final expression, which is Gm2 Rd times Rb plus 1 by Gm1 upon Rb plus Rs plus 1 by Gm1. So I'm sure this is going to be one of the options. Okay. So let us move on to the audio బాగానే ఉంది కదా సార్? ఆడియో బాగానే ఉందా? వింటున్నారా? ఓకే ఓకే. Let's move on to the next question. So the previous one was Q7. This is also another 2-mark question. Okay. Again, I'll just briefly present the question. Okay. So there is some NMOS transistor operating in the linear region, with a drain current of 5 microamps at a drain to source voltage of 0.1 volts. This is like statement 1. And then to this transistor, they are doing something while keeping VGS constant. So VGS is held constant, but the value of VDS is increased from its initial value of 0.1 volts to a new value which is 1.5 volts. Okay. What is also given in the equation, the transconductance parameter, that is mu n Cox W by L, it is given as 50 microamp per volt square. And the question is what this? What is GM at the new operating point? So what is the value of the transconductance GM at the new operating point? And this must be found in, so GM equal to dash microampere per volt. In other words, you have to find the new value of GM in units of micro Siemens. Okay. So initially it is operating in triode, and the new operating point is what? VDS equal to 1.5. So first we need to determine at the new operating point, is the transistor going to continue in triode or is it going to switch to saturation? Okay. So for that we need to compare VDS with the gate overdrive voltage, that is VGS minus VTH. So from the given first statement we can find the overdrive voltage. Since it is given that it is operating in linear, which is otherwise called as triode. In triode, you know, the drain current is given by mu n Cox WL times VGS minus VTH times VDS minus half VDS squared. Okay. So what is the drain current? It is 5 microamps. Mu n Cox WL is what? 50 microamp per volt square. VGS minus VTH, that is what we are trying to find. VDS is what? 0.1 minus half VDS square. 0.1 square is 0.01 by 2 is what? 0.005. Okay. Now this microamp and microamp will get cancelled. Volt square and volt square also will get cancelled. Okay. Anyway, so when you cancel out micro, 5 by 50 is what? 1 by 10, which is 0.1. So VGS minus VTH is what? 0.1 plus 0.005, which is 0.105 divided by 0.1. So VGS minus VTH is what? 0.105 by 0.100, 105 by 100, which is 1.05 volts. This is your overdrive voltage. Now what is the new value of VDS? It is 0.1, sorry. It is 1.5 volts. New value of VDS is what? 1.5. Is it not clearly more than the overdrive voltage? So this is greater than VGS minus VTH. That means what? The new operating point is what? In saturation. What is GM in saturation? What is the transconductance in saturation? It is simply mu n Cox W by L times VGS minus VTH. Okay. So mu n Cox W by L is what? 50, this thing. So 50 microamp per volt square into VGS minus VTH. Just now we found it as 1.05 volts. So the answer is what? 50 into 1.05 microampere per volt. 50 into 1.05 microampere per volt. So this will be slightly greater than 50. Yes. What is 50 into sorry, you calculate cheyandi. 50 into 1.05. So this is what? 52.5 microampere per volt. That is the transconductance GM at the new operating point. Okay. So we still have two more questions. So next question is also what a 2-mark question. In this question, they have given what a mass cap with a p-type substrate. They have given a mass cap with p-type substrate, and the thickness of the oxide layer is what, some 100 nanometers, and the oxide trap charge at the SiO2 interface is also given, and it is what, 10 power minus 8 coulombs per centimeter square. And the metal work function, that is what, the work function of the gate is what, 4.6 eV, and the relative permittivity of the oxide layer, that is SiO2, is what, some 4, and the permittivity of free space is what, the standard value, 8.85 times 10 to the minus 14 farad per centimeters. What is also given, it is given that the flat band voltage of the mass cap is what, 0. So given that the flat band voltage of the mass cap is what, 0, what is the work function of the p-type substrate? Work function of the p-type substrate is dash electron volts. So in other words, you have to find what, Q phi S. So what is this question about? It's about finding the work function of the substrate, which is Q phi S, and it is how many eV. What is given? The flat band voltage, what, 0. What is the expression for the flat band voltage of any mass cap, not just mass cap with p-type substrate? For any mass cap, the flat band voltage, what, phi ms minus qx by cx, and phi ms means what, phi m minus phi s, and then you have the same minus qx by cx, and flat band voltage, what, 0. So from this, what is phi s? It is phi m minus qx by cx. So in the equation, phi m is given. In fact, q phi m is what, 4.6 eV. So phi m is what? Okay, I'll just continue from here. So q phi m is what, 4.6 eV. Q and D are identical. So phi m is what, 4.6 volts. Okay. So phi s is what, 4.6 minus qx, which is 10 power minus 8, divided by Cox, which is epsilon ox by Tox. Oxide capacitance per unit area, which is epsilon ox by Tox. Okay. So what is epsilon ox? It is 4 times 8.85 into 10 to the minus 14 divided by Tox. What is Tox? 100 nanometers. 100 nanometers is what? 100 into nanometers is how many centimeters? 10 power minus 7, right? Ten power minus 7 centimeters. 100 into 10 power minus 7 is what? 10 power minus 5 centimeters. So 10 power minus 8 by this thing. So Tox will go to the numerator. So in the numerator, you simply write 10 to the minus 5. Okay. So from here, you should be able to get the value of phi s. Oksari value cheptara. Ten divided by, say, just do this calculation. 10 divided by 4 times 0.28. Okay. 0.2824 minus 4.6. Okay. 4.32 volts. That is what? Phi s. But the question is what? To find the work function. This is what? Work function potential. All you have to do is what? Just multiply it with E. Okay. So Q phi s will be what? 4.32 electron volts. It's a very, very simple question. Given that you know this, formula or relation. VFB is equal to what? This. Okay. So now we are going to the last question from EDC. Again, I don't have the complete statement, I just have the numbers, okay, data. There is what? Non-degenerate N-type semiconductor Q9. There is what? Non-degenerate semiconductor which is N-type, and it has 5% neutral. It has what? 5% neutral donor atoms. We will get to this. It is also given that the separation between the edge of the conduction band and the Fermi level, that is EC minus EF, it is what? 0.25 eV, 0.25 eV, and the donor level has a degeneracy factor of 2. Has a degeneracy factor of 2, and the value of Vt, that is the thermal voltage, it is what? 20 millivolts, and you are asked to find the separation between the conduction band edge and the donor level. Okay, you have to find what? EC minus ED is how much, or how many electron volts? How many electron volts? Okay. నడుస్తుంది కదా ఓకే this degeneracy factor is something I have been teaching over the years, but it has never appeared in any exam, but this is the first time that they have finally asked this question based on degeneracy factor. So for the donors which will result in additional energy states at the donor level, the the degeneracy factor is what? 2, whereas for acceptors it is what? 4. Okay, because say whenever a donor atom gets ionized, that extra 5th electron will leave the donor level and jump into what? The conduction band, and in this process whatever energy state that you have at the donor level, it becomes vacant. Now that vacant energy state at the donor level can be filled in 2 different ways. You can put an electron with a positive spin. You can also put an electron into that vacant state with a negative spin, +half and -half. So the funda is what? This. So if you have a vacant energy state at the donor, that vacant energy state at the donor can be filled in 2 different ways. So each vacancy or each vacant state at the donor level should be effectively counted as what? 2 available states. If a state is already filled, we can't do anything about it, but if a state is what? Unfilled, then you can fill it up in 2 different ways. So effectively it should be counted as 2 energy states. What is it? Any unfilled state at ED level should be counted as what? 2 effective energy states. Now let us again read the question from the beginning. Non-degenerate semiconductor N-type, that means what? You are adding donors, has 5% neutral donor atoms. What is the concentration of neutral donors? It is what? ND0, those donors which do not get ionized. Okay, so donor will donate a free electron only after it gets ionized, for which the electron should jump from ED level into the conduction band. So what are they saying? ND0 is what? 5%. 5% of what? 5% of the number of donors that is added. So 5% of ND. So ND0 is what? 0.05 ND. In that case, what is ND plus? Because when you had 100 donors, and if 5 donors are not getting ionized, remaining 95 are getting ionized. Okay, so Nd plus is what? 0.95 times Nd, because what is the relation between Nd, Nd naught and Nd plus? Nd is what? The total number of donors that is added, out of which the number that gets ionized is what? Nd plus, and the remaining is what? Nd naught. So always Nd is equal to what? Nd naught plus Nd plus, Nd naught plus Nd plus. Now let us write the expression for f of Ed. F of Ed is what? The Fermi function at the donor level. At the donor level, how many energy states will be created in the first place? Nd number of energy states will be created per unit volume, and out of those Nd energy states that are created, Nd naught will remain vacant, Nd naught will remain filled, and Nd plus will become what? Unfilled. Okay, maybe I should write it here. So Nd naught represents what? The filled energy states at Ed level, whereas Nd plus represents what? The unfilled, because after getting ionized, the electron will leave the Ed level and go into the conduction band. But due to this degeneracy factor, donor level has a degeneracy factor of 2. Due to this degeneracy factor, if I ask what is the effective number of unfilled states at Ed, you should say it is what? 2 Nd plus. So due to what? Due to this degeneracy factor, the effective number of unfilled states at Ed level should be taken as what? 2 times Nd plus. Okay. Now let's get back to this f of Ed. F of Ed is what? Fermi function. Fermi function is what? The fraction of states which are going to be filled. Fraction of states which are going to be filled. So what is the number of states that are filled? It is what? Nd naught divided by the total number of available states at Ed level. Total number of available states at Ed level is what? Filled plus unfilled. Filled is what? Nd naught. Unfilled, it is not Nd plus. Due to degeneracy factor, you should take it as what? 2 Nd plus. Okay, that's all. So whoever writes this 2 will end up getting the right answer. This is the whole point about this question. Okay. And now what we can do is, okay, Nd naught is what? 0.05 Nd. This is also what? 0.05 Nd. And Nd plus is what? 0.95 Nd. 2 times 0.95 is what? 1.9. Correct? 0.9, 1.8, 1.9 Nd. Now Nd is what? Common to both numerator and denominator. So it is what? 0.05 upon 1.95. Sorry. So f of Ed is what? This 0.05 upon 1.95. Okay. Now you write the general expression for the Fermi function at the donor level, which is 1 upon 1 plus exponential Ed minus Ef by Kt. And what is this? Equal to 0.05 by 1.95. I think this can be written as what? 5 by 195. 5 by 195 is what? 1 by, what is 5 by 195? 0.02? 0.0256. Okay. Actually, it is not required. I'm sorry. We'll just leave it as 5 by 195. By 195. By 195. Now this factor will go to the other side. Even this 5 by 95 will come to this side. Then it becomes what? 195 by 5. 195 by 5 is what? 39. Yes, 39, and then 39 minus 1 is what? 38. So you'll get this exponential ED minus EF by KT is what? 39 minus 1, which is 38. Now you take natural logarithm on both the sides, then you'll get ED minus EF is equal to KT ln 38. Please note that KT is not the usual 26 millivolts. KT is what? Because VT is what? 20 millivolts. KT will be what? 20 milli electron volts. Okay. So 20 milli electron volts times ln 38. 20 times ln 38. 72.7. So this is what? 72.7 milli electron volts, which is also same as, I think, milli means what? You have to divide it by 1000, right? 0.0727 EV. But what is the question? It is to find EC minus ED. What is already given? EC minus EF is given. Yes. EC minus EF is what? 0.25 EV, that is given in the equation. And by doing all this analysis, in the end we found that ED minus EF is what? This much. ED minus EF is what? 0.0727. Now you have to find what? EC minus ED. You have to find what? EC minus ED. Call this equation 1, call this equation 2, subtract equation 2 from equation 1. Straight away you will get EC minus ED, and it is 0.25 minus 0.0727. This is going to be the final answer. 0.25 minus 0.0727. 0.1773 EV. This is the separation between EC and ED. I hope the concept of degeneracy factor is clear. Okay, this is the first time they have touched this particular aspect of the degree of ionization. So altogether there were 10 questions from EDC, and I have discussed each and every question in complete detail. Yes, now I'll take a break. I'll hand it over to Shankar sir, who will take you through the control systems questions from today's paper.
Now let us look into control systems questions of this GATE 2024 EC paper. Total from this subject there are 8 marks. Out of that 2 questions of 1 mark and 3 questions of 2 marks each, total 8 marks. Now let us look into the first question. In a Bode magnitude plot, a slope of 40 dB per decade is equivalent to, it is given if by observing the options, it is given in terms of slope per decade in the dB scale, what is it is equivalent of in the octave scale. So we know that minus 20 dB per decade is equivalent of minus 6 dB per octave, and minus 40 dB per decade is equivalent of minus 12 dB per octave. But here the slope is given in terms of positive, therefore because of the logarithmic scale, that minus will be replaced with a plus. So the correct option will be (12 dB per octave). Now this is a 1 mark question. Now let us move to 2 marks question. Now in this problem, now let us read it. In the following control system, the forward transfer function is given as 6 divided by s multiplied with s plus 1 into s plus 2. Now the question is, of course it is also mentioned that we can easily understand r of t, e of t and y of t are input signal, error signal and output signal respectively. Now the input is unit step function. So what do you mean by that? R of s is equal to 1 by s. Now what is so by of course question is not mentioned, by seeing the options we can easily understand that what is the value of limit t tends to infinity e of t. It is simply nothing but steady state error. So steady state error, how can we write? E of infinity is equal to limit t tends to infinity e of t. This is equal to limit s tends to 0 s multiplied with e of s. Now this is very straightforward question. We need not to do any further calculations. Why? Because by observing the forward transfer function of the given control system, that is a type 1 system, because there is one pure integration at the origin, or we can also say that one pole at the origin in the forward transfer function of unity feedback control system. Now whenever there is a pure integration in the forward transfer function, for the step input the steady state error obviously will be 0. Therefore for this question the answer, the correct answer will be limit t tends to infinity e of t will be 0. In other words, the steady state error will be 0. Now this is also given for 1 mark question. Now let us move to the next problem. Now this question is 2 marks question, and this problem is a little bit lengthy, and we will see how to approach this. A control system is described in the state space form as follows. Some state space equation is given. First one is a state equation. Left hand side is a derivative of the state variable is equal to 0 minus 2 1 minus 3 into state vector plus 1 0 and r, where r will be the input, and output equation is also given, y is equal to 2 minus 5 into state vector x. Which of the following has or have the same transfer function as the given system? So first let us look into what is the transfer function equation. So what do we have to do for the given system? First we will try to find out what is the transfer function, and from then for all the 4 options we need to cross check what is the transfer function and we have to match it. So first let us see what is the g of s transfer function. C multiplied with s I minus a inverse into b. Okay, so first let us try to find what is s I minus a matrix. So this means s 0 0 s minus. Now from the given system, substitute the matrix A row wise 0, -2 and 1, -3. So this will give you S 0 minus of -2 will be +2, 0 minus 1 -1, and this is a S plus 3. So this is a Si minus A matrix. Now Si minus A inverse, Si minus A inverse. So how to find an inverse matrix? Adjoint of Si minus A, denominator determinant of Si minus A. So what you can write down here, 1 by determinant S into S plus 3 will give you S square plus 3S AD minus BC. So minus of minus will give you plus 2. Now adjoint, interchange the diagonal elements S plus 3 and here it is S, and change the sign of non-diagonal elements, that is -2 and 1. So this is a Si minus A inverse. Now the transfer function will be C into Si minus A inverse into B. So this will be, now the C is a vector 2 minus 5. Now Si minus A, S plus 3 minus 2 1 S, and B is a column vector 1 and 0 divided by S square plus 3S plus 2. Now by simplifying this we will get numerator 2 minus 5, here S plus 3 into 1 will give you S plus 3 minus 2 into 0, 0. So the first element is S plus 3, and in the column wise 1 into 1 plus S into 0, it will give you 1, and here S square plus 3S plus 2. Therefore the transfer function G of S is equal to 2S plus 6 minus 5. So that will be 2S plus 1 divided by S square plus 3S plus 2. So this is the transfer function. Now we need to verify for all the transfer functions, for all the options, we need to find out what is the transfer function. So I cross checked that it is matching with the option D. In the option D also, for the given state space equations, transfer function it is coming around 2S plus 1 divided by S square plus 3S plus 2. It is a little bit lengthy, and I came to know from the students that it is time consuming, but however continue na? A plus 2 into s square, next 2a plus 4 into s plus 4a is equal to 0. Now, let us call this is the equation number 2. So, by introducing the compensator, whatever characteristic equation we have, if you compare the coefficients with the pole location, required pole locations of a characteristic equation. So, let me write down this equation once again. S cube plus 4s square s cube plus 4s square plus ks plus k alpha, ks plus k alpha is equal to 0. Now, if you compare the coefficients one by one, we can have a plus 2 is equal to 4, hence it will give you a value is equal to 2, and k is equal to, this k is equal to 2a plus 4, hence k is equal to 4 plus 4, it will give you 8. Then finally, k into alpha is equal to 4a, that means 8 into alpha is equal to 4 into a, that is 2, it is 8. Hence finally, it will give you alpha is equal to 1, okay, alpha is equal to 1. So, by seeing the complete system diagram or compensator transfer function, GC of S is equal to k into S plus alpha divided by S plus 4. So, what it is, k value 8 into S plus 1 divided by S plus 4. Even though it is asked only alpha value, I calculated k also. So, k value is 8, alpha value is 1. With that, what are the pole locations? Closed loop pole locations are located at minus a, that is minus 2 and minus 1 plus or minus j root 3. So, the final answer for this question will be alpha value is 1. So, this is the answer. Now, let us go to another question. Now, another question is, the forward transfer function in the control system shown in the figure is g of s is equal to k by s plus 1 into s plus 2 into s plus 3. The impulse response of the closed loop system decay faster than e power minus t if. Now, here there is a one important statement here, impulse response, in other words overall response of the system decay faster than e power minus t. So, what do you mean by that? The closed loop poles should be located left hand side of this minus 1, okay. So, in this case the concept is, what is the condition for k? For that, the closed loop poles should be left hand side of the S plane. So, this is the concept of relative stability analysis. This is the concept of relative stability analysis. So, for this, what you have to do, you need to define a new plane, let us say Z plane, in such a way that S has to be replaced with Z minus 1, with the new variable define the characteristic equation, and find the condition for the new plane, the closed loop poles to be left hand side of that new plane. So by using Routh's method you can do that, but in this case first let us write down characteristic equation of the original system. Okay, so characteristic equation of original system, that is 1 plus k divided by the given transfer function s plus 1 into s plus 2 into s plus 3 is equal to 0. Now suppose by finding the characteristic equation here, and if you apply Routh's method or a Routh's table, then you will get the condition for k in such a way that closed loop poles of the original system to be left hand side of the j omega axis. But here we want the closed loop system should be decay faster than e power minus t. That means you have to check the condition for k in such a way that the closed loop pole should be left hand side of minus 1. Then what you have to do, we should substitute new variable. So that is s is equal to, substitute s is equal to z minus 1. Okay, now with this new variable, if let us redefine the characteristic equation. So it will be 1 plus k divided by, if you substitute s is equal to z minus 1, you will get z multiplied with z plus 1 multiplied with z plus 2 is equal to 0. So with this new variable, what will be the characteristic equation? So that is z into z square plus 3z plus 2 plus k is equal to 0. Then you will have z cube plus 3z square plus 2z plus k is equal to 0. Once you got this characteristic equation, now define Routh's table. So the Routh's table, z cube elements 1, 2, z square element 3 and k, z power 1 row 6 minus k divided by 3, z power 0 element k. Now here for the system to be relatively stable with respect to minus 1, what is the condition here? The first column elements should be positive. So k should be greater than 0, 6 minus k should be greater than 0. In other words, k should be less than 6. Therefore, the range of k will be 0 less than k less than 6. Okay, so with that the appropriate options can be 1, 2, 5, that will satisfy 0 less than k less than 6. So this is the concept from relative stability analysis. So the only twist in this question is, indirectly it is mentioned that relative stability analysis, it is mentioned that the closed loop system should be decay much faster than e power minus t. So this question is also for 2 marks. So with this total 8 marks from control systems, and now another faculty, I think Hemant sir will take a next subject. Thank you.
Okay, so next we look at the questions from digital circuits. So from digital circuits, this year we have a good amount of weightage. We almost have 11 marks from digital circuits, wherein we have 3 1 mark and 4 2 mark questions. Okay, yeah, so this is one of the 1 mark question we have. So we have been given a Boolean function in terms of min terms format, and by using that we are supposed to find out the essential prime implicants. Okay, so we have to find out EPIs specifically. So this is a straightforward question. There is no great twist in this question. So for this we have to construct the K-map first. So let me construct the K-map. Yeah. So let's assume that the variables are A, B, C, D. So we have A, B, C, D as the variables. Now let's populate the K-map by using the min terms given to us. We have min term 0, we have min term 2, 5, 7, 8, 10, and then lastly 12, 13, 14 as well as 15. Okay. So by looking at this K-map, if at all we have to group the ones, the reason why we have to group ones is because this is in fact the finding out prime implicants. So in the finding out prime implicants we have to group ones. So let's group this particular grouping of ones. The corners form one more grouping. Okay, and then we have 2 more ones, and those 2 ones can be grouped in this specific manner. Let me use a different color here. So the corners form one grouping, and then these 4 ones form one more group, and then we have one more last grouping here, and the last grouping would be grouping of these 2 ones with respect to the 2 ones here. Okay, so here the definition of essential prime implicant is, I'm sorry, I think the So here, since we are supposed to find out the essential prime implicants, we have to find out the ones which are grouped by only one single grouping. Here we'll talk the grouping in terms of colors. We have a pink group, we have a blue group, then we have a white group, and then we have a orange group. So total we are having 4 groupings. All these 4 groupings can be called as prime implicants, but out of these 4 prime implicants we are supposed to find out which are essential. So for that we have to find out ones which are a part of only one single grouping. Okay, so if you see this one, this is a part of only one single grouping. Again, this one part of one single grouping, and furthermore these 2 ones. If you notice, these 2 ones again part of only one single grouping. So if you see how many groupings have these starred ones, we only have 2 groupings which have these starred ones. One being the pink grouping, and one more being the blue grouping overall. Okay, so that's it. These form the essential prime implicants. So let's write this in terms of expression format. So the pink grouping can be called as, in this corner grouping we have A changing variable, B non-changing variable, B is 0 and hence B bar, and again in these 2 columns we have C changing variable, D non-changing variable, D bar, and then again the blue grouping we can call it as, in fact, B is 1 true form, and then again here D is 1 true form. That's it. So we have 2 essential prime implicants, namely B bar, D bar and BD. Okay, yeah, so this is in fact a straightforward question, a simple question. Next, this is a good question. This is a 1 mark question. In a number system of base R, we have been given equation. Usually previously we have been given additions, multiplications in the base conversion, but rather here we are supposed to find out a base which satisfies this specific equation. Okay, so because of that what I'll do is I'll write each of the given terms here in the form of the given base. So what is 12? I can see a number 12 here. 12 to the base r is equal to dash in terms of base 10. Let's convert everything in terms of, or everything into base 10 format, because all arithmetic operations we do will be in terms of base 10 format. This is r plus 2. Okay. Next we have 37. 37 to the base r becomes equal to, this is 3r plus 7, both in terms of base 10. Okay. Now we'll write this entirely in the form of base 10 format, and hence I'm finding out the value of this. X is a unknown, x is a 8, the value of x is 8. So this is 8 into 8 minus 12. 12 will be written as, in base 10 format, r plus 2 into x, x is equal to 8, plus 37, 37 is equal to 3r plus 10. So entire calculation now is being done in terms of base 10 format, decimal format, which becomes equal to 0, right? Now, since we have converted everything in terms of decimal, we can do the normal decimal calculations. 8 into 8 is 64, minus we have 8 into r, 8r, minus 16, plus this is 3r plus 10 is equal to 0. So now all we have to do is solve this equation. We have 64 plus 10, that is, sorry, this is 3r plus, we have 3r plus 7, this is 3r plus 7, 3r plus 7. So 64 plus 7 is 71, 71 minus 16 is 55. So we have 55 minus 5r being equal to 0, and r value here becomes equal to 11. So for this question the base value is 11. So you have to get this idea that, okay, the given equation is given in terms of base b or base r. Now we are comfortable with always calculations in base 10. So let's convert this entire equation into base 10 format, and if you write everything in terms of base 10, the problem is complete. Okay. Again, this is fairly easy question if you know the basic concept of base conversion. Okay. Next, this is a 2-mark question. This is a counter based question. We have been given a synchronous counter, and we are supposed to find out the state sequence for this counter. Now in case of synchronous counter questions, all we have to do is construct the state table. The moment you construct the state table, your task is done. So I'm writing the present state here first. Present state consists of Q1 as well as Q2, sorry, Q0. And then on the basis of that, we find out the present inputs, and then we find out the next state on the basis of the present inputs. What is the present inputs? Present inputs will be, one is T1 and one more is T0. What is T1 from the previous circuit? T1 is equal to, this is OR gate, input is Q1, one more input is Q0 bar. So this is OR of Q1 as well as Q0 bar. And furthermore, similarly, what is T0? T0 is equal to, this is OR of Q1 as well as Q0. So this is simple equation. So T0 is equal to Q1 plus Q0. And then on the basis of that, we'll find out next state Q1, Q0. Okay. 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 So now we can assume any initial state. I'm assuming the initial state to be 0, 0. So in this case, what is the value of T1? This is 0 plus 0 bar, 1. T0 is 0 plus 0, 0. T1 is 1, and hence Q1 toggles from 0 to 1. T0 is 0, and hence the Q0 state remains same, 0 remains 0. Now that 1, 0 will appear as the present state here. So we have 1, 0 as the present state. Now what is T1? T1 is Q1. Q1 is 1. 1 plus anything is anyway equal to 1. What is T0? Q1 plus Q0, and hence 1 plus 0 is 1. Both inputs are 1. T1 and T0 both are 1. So hence both outputs will toggle. Q1 will toggle, Q0 will toggle, Q1 will toggle from 1 to 0, Q0 toggles from 0 to 1. So 1 0 becomes 0 1. Okay. Now if the present state is 0 1, then what is the value of T1? T1 becomes equal to Q1. Q1 is 0 plus 1 bar. So 0 plus 1 bar is nothing but 0. T1 becomes 0 and T0 is addition of both of the 0 plus 1 is anyway equal to 1. Okay. So now the state of T1 remains same. T1 state is 0, so 0 remains. And the state of T0 is toggling because, the state of Q0 will toggle because of T0 1. T0 is 1 means 1 becomes here 0. And hence we are back to the initial state. If you look at, we started by taking the initial state as 0 0. Okay. After 0 0, the next state is 1 0. And after that, the next state is 0 1. And finally, we are again back to the state 0 0. Okay. But here, we covered 3 states, we didn't cover 1 state. So let us see what will happen whenever you take the last state. The last state being, in fact, 1 1. Okay. So if the present state is 1 1, then what is the value of T1? T1 is 1 plus 0 bar 1. And what is the value of T0? T0 is 1 plus 1 1. And both T1 as well as T0 are equal to 1, and hence both outputs will toggle. So 1 1 toggles to 0 0. So means if the present state is 1 1, the next state is equal to 0 0, right? Now on the basis of this, we will construct the state diagram. So state diagram for this question would be, so if you start with 1 1, in fact, the next state is 0 0. But if you start with 0 0, the next state is 1 0. So the next state is 1 0. And after 1 0, the next state is 0 1. And after 0 1, the next state is 0 0. That's it. So we have to choose an answer which actually gives you this kind of a state diagram. So this is in fact being matched with I would say I think option B. Option B, if you notice, the examiner is starting with the state 1 1, and if you are starting with the state 1 1, the next state would be definitely 0 0. You are going to 0 0. After 0 0, it is 1 0, and then 0 1, and then again back to 0 0. That is what you have in the option B. Again, this is a fairly straightforward question if you know the basic operation of synchronous counters. Okay. Yeah. Next. Yeah, this is a nice question. So this is a multiplexer based question. So we have a 2 1 mux here. This is our 2 1 mux, and the 2 1 mux is a non-ideal mux. So it has a delay of 10 nanoseconds. So the delay of the mux is 10 nanoseconds, and the propagation delay of inverter is 0. So this is ideal in fact. So this inverter is ideal, whereas the mux has some delay. The delay of the mux is 10 nanoseconds. So if the S input, the select line is set as 1, then what is the value of output? How output behaves whenever the set is equal to 1? So that's what you are supposed to answer. So whenever the set input becomes equal to 1, the connection is the input 1 to the output, that is a connection. So S is equal to 1 means the connection is 1 to output. So this is a connection. So if you notice, you can observe one interesting path here. I'll show you the path here. So yeah, so this is the path. If you notice, the signal is actually taking this path. If you look at the functionality of this path and write it in a different manner, we can say that this is equivalent to a NOT gate with feedback. Okay, a NOT gate with feedback. How will a NOT gate with feedback functions? It always functions as a oscillator. Okay, so this is in fact functioning as oscillator. Okay, so definitely the answer is not A as well as B, because the output cannot be constant in an oscillator. Okay, so it has to be a square wave of either 50 megahertz or 100 megahertz. So the next task is find out what is the frequency of operation. So you know that whenever you have a circuit of this particular format, so for this circuit, what is the frequency of oscillation? The frequency of oscillation becomes equal to 1 by 2n TPD. So usually whenever we use this formula, we say that this is the TPD of, that is the propagation delay of the NOT gate, but in this context the NOT gate delay is 0. But overall path delay, is it equal to 0? No, the overall path delay is not 0. So whatever is TPD here, we will write it as nothing but the path delay overall, the closed loop path delay. So in the closed loop, the overall path delay is nothing but the NOT gate has no delay, but rather through the mux, whenever the signal is crossing through the mux, it has a delay of 10 nanoseconds. And how many number of inverters we have here? Only one single inverter. So I would say this is simply the NTPD, whatever is there, that is the delay of the forward path. So in this case, in the forward path, the delay is equal to simply 10 nanoseconds because of multiplexer, and hence I will write this as, so this entire value becomes equal to 10 nanoseconds. And finally, the frequency of oscillation is 1 by 20 nanosecond. This is 1 by 20 nanosecond. And when you do the calculation, 1 by 20 nanosecond becomes equal to 50 megahertz. Okay. So if you understand the logic here in this question, yeah, this is a very straightforward question. Okay. But yeah, some people what they do is they also explain it by a different manner, wherein they draw the waveform. You can also explain this question by drawing the waveform, but rather that is a pretty lengthy process. Okay. But if you understand the simple logic in this question, yeah, hardly this will take some 1 minute or 2 minutes of time to solve this question. Okay. Yeah. Next. So this is one question that has not been asked in GATE exam till now, which is a priority encoder question. So the priority encoder has overall 4 inputs. So let me draw the block diagram for this. So we have a priority encoder with 4 inputs. The 4 inputs are, we have D3, D2, D1 as well as D0. So this is D3, D2, D1 as well as D0. And on the output side, we have 2 guys, namely A as well as B, wherein A is MSB and B is LSB. Okay, and this is our priority encoder. Okay, and the priority order is also given. The priority order itself is D3, D2, D1, D0. So D3 has highest priority, so I would say D3 has highest priority, and then D2 has the next highest priority, and then D1 has the next highest priority. And then lastly D0. Okay. So whenever D3 is active, examiner told us that corresponding to D3, the output is 0, 0, corresponding to D2 it is 0, 1, and corresponding to D1 it is 1, 0, and corresponding to D0 it is 1, 1. Usually we will be given reverse order. Okay, 1, 1 is for D3, 1, 0 is for D2, and 0, 1 is for D1, and 0, 0 is for D0. Here examiner gave you in reverse order. Okay, and finally you are supposed to find out the minimized expression for this input B. That's it. Okay, so since we have a priority encoder, whenever D3 becomes equal to 1, then I don't care about D2, D1, D0. Irrespective of their values, don't care. I would say that AB becomes equal to how much? 0, 0. Whenever your D3 is active. Okay, and whenever D3 is not active, but rather D2 is active, so D2 becomes 1, then we don't care about D1, D0. D1, D0 is don't care. So in this case, what is the value of AB? AB becomes equal to 0, 1. Okay, next D3, D2, D1. Let's assume these values are 0, 0, 1. D3 is not active, D2 is not active, but D1 is active. Then we don't care about the value of D0. And in this case, what is the value of AB required? The value of AB required is 1, 0. And lastly, whenever D3, D2, D1, D0 becomes equal to all zeros 1, So that is when the value of AB becomes equal to 1, 1. Okay. Yeah. So on the basis of this, we have to construct the K map for the output B. So let me construct the K map for the output B. Okay. It will be definitely a 4 variable K map having the inputs as D3, D2, D1, D0. So this is D3, D2, D1, D0. So in the last two rows, if you notice, the value of D3 becomes 1. Whenever D3 is 1, the value of B becomes equal to 0. So here we have to populate zeros. See here, whenever D3 is 1, I don't care what is the value of D2, D1, D0, irrespective of rest all three inputs, the output value has to become equal to 0. Okay. So whenever D3, D0 is equal to 0, 1, in the first case, we verified only D3 being 1. But now we are verifying D3, D0, or sorry, D3, D2 being equal to 0, 1, which happens in this row. So when D3, D2 is equal to 0, 1, then the value of B becomes equal to 1, and hence B becomes equal to 1 here. Okay. Next, D3, D2, D1 being equal to 0, 0, 1, which happens in these two cells. And whenever D3, D2, D1 is equal to 0, 0, 1, AB value becomes equal to 1, 0. So AB value is in fact being equal to, B value is equal to 0. And then D3, D2, D1, D0 is equal to all zeros 1. So which happens in this particular cell. And there, what is the value of B? The value of B is equal to 1, and hence I am placing a 1 here. Okay. So no information is given about D3, D2, D1, D0 being equal to 0, 0. So in this case, output should become equal to either 1 or 0. That information is not there, and hence I can take it as don't care. Okay. So here I am taking this as don't care, because for that specific combination of inputs, how should the output behave? No information regarding that, and hence I am taking it as don't care. So now you can form groupings. We will get overall two groupings here. One is this quad, and one more is this quad. Okay, write them in the minimized expressions format. So this quad in fact is D3 bar D2. So this is D3 bar D2, whereas this quad becomes equal to, this is the D3 bar D1 bar. So this is D3 bar D1 bar. Okay, and if you go by the options, there is only one option which is matching that, which is D3 bar D2, yeah, D3 bar D2 and D3 bar D1 bar, which is option D. Okay, D is the correct answer here. Again, this is a simple question. If you know the basic functionality of priority encoder, even if you don't know the functionality of a priority encoder, the functionality is given to you in the question itself. All you have to do is construct the K map, and your problem is complete. Okay, yeah. So this is next question. Then we have one more question on ADC topic. Yeah. So a full scale sinusoidal signal is applied to a 10-bit ADC. So we have a 10-bit ADC. Okay. And the fundamental signal component in the ADC has a normalized power output of 1 watt, and the noise and distortion has a power of 10 microwatt. Then the number of effective bits in the ADC is dash. So we have, I think, options as 7, 8, 9, 10 are the options. And let me write the options also for this. The options given are 7, 8, 9 and 10. Okay. Okay. So here we have to know what is the SNR in this question. We have to know the signal to noise ratio. Signal to noise ratio, namely SNR, for this ADC. And that too we have to find out the SNR in terms of dB decibels. So SNR in dB is equal to, this is 10 log of signal power to the noise power. Okay. So signal power is given as 1 watt, and whereas the noise power is given as, I think, 10 microwatt. So this becomes equal to, this is 10 log of 1 divided by 10 micro is 10 into 10 power minus 6, which is 10 power minus 5. Okay. So this becomes equal to log of 10 power 5, which becomes equal to in fact 50. Okay. But at the same time, we also know what is the formula for SNR dB in case of ADC. Okay. So in case of ADC, having some n bits, so the SNR value is given by, this is 1.76 plus 6.02, which is almost equal to 6 times n. So from this we have 6.02 n being equal to, I think you can approximate this to almost a value of 50 minus 1.76. Can you do the calculation? I think 48.24. And what is the value of n here? 48.24. I think it is 8 point something. 8.01. Okay. So 8.01, in case of digital circuits, we always round off a particular number to the next integer. We actually seal that number. The sealing of 8.01 is equal to how much? This is 9. Okay. So in this specific ADC, the effective number of bits is equivalent to 9. Hence the correct answer is here 9. So even though we have been given that this is a 10-bit ADC, but according to the given noise power as well as the signal power, we can say that this is equivalent to a 9-bit ADC. Okay. Yeah. So next, the last question we have here in case of digital circuits is a question based on computer organization. So I don't have that question in typing format. I'll write that question. Okay. So here we have a 32-bit computer. 32-bit computer has 40 instructions and 24 registers. Okay. And furthermore, each instruction has an opcode, and then we have 2 source registers and then 1 destination register. And apart from this, we also have one immediate value that we can insert, and one immediate value. So all we have to find out is nothing but what is the unsigned value of this particular immediate value, okay, or the maximum. We have to find out the maximum unsigned immediate value. So even though this question looks like this is in fact a computer organization question, basically this is a very simple number systems question, I can say. So we have initially 40 instructions. Okay. So we have 40 instructions. Okay. So whenever we have 40 instructions, we have to find out the number of bits required for each instruction. So the number of bits per instruction is given by simply sealing of log of number of instructions to the base 2. So this is equal to sealing of log of 40 to the base 2, and log of 40 to the base 2 is 5 point something, 5 point something sealing is 6. Okay. Next, we have 24 registers. So whenever we have 24 registers, how many number of bits we require? Number of bits per instruction. Sorry, number of bits per register. So this is again given by ceiling of log of 24 to the base 2. Ceiling of 16 to the base 2 is 4 and 24 is in between 16 and 32, and hence the answer is log of 24 to the base 2 is nearly 4 point something. 4 point something ceiling is 5. Okay. And what is the size of your each instruction? Each instruction has a size of 32 bits. So if you look at this, okay, so we have a 32-bit instruction. Okay, how is this instruction divided? The instruction is divided into opcode, first part, and then source registers. And how many such source registers you have? 2. And then we have destination register. And how many such destination registers we have? Only 1. And then finally the value, okay, the so-called value, the value of the operand that you want to insert in that last location. How many bits opcode is taking? Opcode is taking here, just now we have seen, this is taking 6 bits. Each source register will take 5 bits. So we have 5 into 2, because we have 2 source registers, 10 bits. Destination register we only have 1, so 5 into 1 will take 5 bits here. Okay, so this is 6 bits. 5 into 2 is 10 bits here. 5 into 1, 5 bits here. This is unknown value. We have to find out this unknown value. Okay, so finally I can say now 32 becomes equal to 6 plus 5 into 2 is 10 plus 5 plus unknown value x. Now what is the value of x? I think this is 11 plus 10, this is 21. 32 minus 21 is 11. So 11 bits overall are being reserved for the operand value. Okay, so 11 bits per operand value. And finally you are supposed to find out what is the maximum value of this operand value. So means we have to find out what is the maximum unsigned 11-bit number, because we have 11 bits in case of operand. Okay, so now the final part of the question is, here we have to find out the maximum 11-bit number. The maximum 11-bit number is given by simply this is 2 power 11 minus 1. I think 2 power 11 is 2048 minus 1 is 2047. Okay, so the answer for this question is 2047. Yes. Yeah, so with this the questions on digital circuits are complete. So like I told, we have a good amount of weightage from digital circuits this year, and more or less all the questions are easy only, except this is one question which is kind of a bit tricky question. And but if you know the basics of again number systems and binary codes, any person can answer this kind of a question. And then one more question we have is the ADC question, which is again you have to be a bit aware of the formula, so to answer the ADC question. Okay, yeah. So next we have mathematics by Lakshman sir. Okay.
Can I start? Okay. All right, guys, let's look at this question now. So if you read all the 4 statements, you need to ask yourself which one out of these is the most general one, okay? So in parajumbles, what is the sentence order that we follow? We go from general to the specific, okay? Out of these 4, if you notice, this statement, Shifu once proclaimed that all life is illusion, okay? This is one general statement. Rest of the 3 statements, P, Q and S, are related to one particular instance, okay? So that means R is the most general one. It introduces the idea. So you can clearly eliminate A and B because we need R in the beginning. That means either C or D is the answer. Let's look at now RS or RP, okay? If we can just find this out. Now notice how article knowledge will help you here. So if you notice here in this statement, it says a bull, okay? And then in P option, it says the bull. Then in Q option, again it says the bull. From the articles knowledge, we have seen that we use the when the idea is repeated and we use a or an when the idea is introduced. That means, let's look at this statement now. S, it introduces the bull. That means the S statement should precede P and Q, okay? So the correct answer here will be C, okay? Because we have found RS is our mandatory pair. No need to look further. No need to decide PQ sequence. We know RS is the pair, so C is the answer. Okay, let's look at the next question now. This one. All right, vocabulary question. So if you notice, quite an interesting pattern that we have seen here for the first time. So if you notice, charm, enamor, bewitch, all are kind of synonyms. They are related to what? Attraction or fascination. Now let us look at the next 3 words, bored, dash and weary, okay? Bored and weary, both are related to the feeling of tiredness, right? That means the word that we are looking for should also be related to tiredness, okay? With varying degree of intensity. Now here you needed some sort of vocabulary knowledge, but you could also use to an extent elimination, okay? We know dead means lifeless, so it is nowhere related to tiredness. Eliminated. Then we know baffled means puzzled or confused, so this can also not be the answer. Let's look at jaded and worsted. Worsted means defeated, so you needed to know this word meaning, or you directly know jaded means exhausted. So this fits the bill. This becomes our answer, okay? Certain.
Now we shall solve problems related to the mathematics. In the first question, we are given a matrix A is equals to 1 k 2 1. It's a 2 by 2 matrix, and we need to find the which of these following are eigenvectors of the given matrix A. So we need to find out of these 4 options which are the eigenvectors of this given matrix A. So when x is an eigenvector of A, when x is an eigenvector of A, it should satisfy the equation Ax is equals to lambda x, where x is an eigenvector and this is a scalar, lambda is a scalar value, or we can say eigenvalue. Now one by one option we will check what are these, what out of these 4 which satisfies this equation. Going with the first option, it is a 1 root of 2 by k, it's a printing mistake, 1 root of 2 by k, and this is root of 2k and minus 1, and this is 1 minus root of 2 by k, and this option is root of 2k by root of 2k and 1. We will check one by one option and verify out of these 4 options which are the eigenvectors of the given matrix A. Going with the first option, let me rewrite matrix A 1 comma 1 k 2 1. Coming to the first option, we have 1 root of 2 by k. We shall solve for this equation Ax is equals to lambda x, where lambda is any scalar. If this satisfies this equation, then this vector is a eigenvector of this matrix. If it does not satisfy, then this is not a eigenvector of the given matrix. So A we have here 1 k 2 1. In the place of x, the given vector 1 root of 2 by k is equals to lambda times x, 1 root of 2 by k. So matrix multiplication 1 into 1 is 1 plus k into root of 2 by k will become root of 2k is equals to lambda. This is the first equation we have. And coming to the second equation, 2 into 1 is 2 plus 1 into root of 2 by k is root of 2 by k, which is equals to lambda times root of 2 by k. This is equation 2. These 2 equations should simultaneously satisfy. Then only we can say Ax is equals to lambda x, and then x is an eigenvector of A. From this equation, lambda is equals to 1 plus root of 2k. I will substitute the value of lambda is equals to 1 plus root of 2k in equation 2 and check whether equation 2 is satisfied or not. So 2 plus root of 2 by k will be equals to, in the place of lambda, 1 plus root of 2k into root of 2 by k. 1 plus root of 2 by k is root of 2 by k plus root of 2k into root of 2 by k will become root k in the denominator, root k in the numerator will get cancelled, root 2 into root 2 will become 2. So if we observe here, 2 plus root of 2 by k will be equals to 2 plus root of 2 by k. Hence, this is an eigenvector of A. Coming to the next option, Again we have A is equals to 1 k 2 1, and the next option B is x is equals to root of 2k and minus 1, root of 2k and minus 1. Again we will check with the same equation, Ax is equals to lambda x. In the place of A we have 1k 2 1, and in the place of x we have root of 2k minus 1, which will be equals to lambda times root of 2k and minus 1. If it satisfies this equation, then this is an eigenvector. If it not satisfies, then this is not an eigenvector of this matrix A. So first equation will be 1 into root 2k is root 2k minus k into minus 1 will be minus k, which will be equals to lambda times root of 2k. Let us name it as equation 1. Coming to the second equation, we have 2 into root 2k, 1 into minus 1 will become 1 minus 1, which will be equals to lambda into minus 1 is minus lambda. This is equation 2. So this equation 2 implies lambda is equals to 1 minus 2 into root of 2k. Now I will substitute lambda is equals to 1 minus 2 into root of 2k in equation 1. So root of 2k minus k is equals to, in the place of lambda I have 1 minus 2 times root 2k multiplied by root of 2k, which is equals to 1 into root 2k will be root of 2k minus 2 into root of 2k multiplied with root of 2k. This becomes 2k, 2k into 2k will be 4k. So if we observe this equation, this is not satisfied. Root of 2k minus k is not equals to root of 2k minus 4k. Hence this is not an eigenvector of given matrix A. Similarly, we need to check the other options also, C as well as D. We have C vector is 1 and minus root of 2 by k. One and minus root of 2 by k. This is the third option we have, and the matrix we have 1 k 2 1. Again we need to check the same equation. Ax should be equals to lambda x for x to be a eigenvector of the given matrix. So substitute in the place of A 1 k 2 1. In the x we have 1 minus root of 2 by k, equating it to lambda times the x. Again in the place of x we have 1 minus root of 2 by k. Multiplication 1 into 1 is 1 plus k into root of 2 by k, it will be minus k into root of 2 by k, it will be minus root of 2k, which is equals to lambda. Let us name it as equation 1. The second equation 2 minus 1 into root of 2 by k is root of 2 by k, which is equals to, this is minus lambda into root of 2 by k. This is equation 2. Now let us substitute the value of lambda from equation 1 in equation 2 and check whether the equation 2 is satisfied or not. So 2 minus root of 2 by k is equals to minus, in the place of lambda, 1 minus root of 2k multiplied by root of 2 by k. So it is equals to 1 into root of 2 by k will be root of 2 by k minus root of 2 by k, root of 2k into root of 2 by k. This root k in the denominator, root k in the numerator will get cancelled. So root 2 into root 2 will be minus 2, minus of minus will be plus 2. So if we observe here, 2 minus root of 2 by k is equals to 2 minus root of 2 by k. So this equation is satisfied. So this is an eigenvector of eigenvector of given matrix A. Similarly, we need to check the fourth option also. In the fourth option, the given eigenvector is root of 2k and 1. Okay, root of 2k and 1 is the given vector, and the matrix is same 1k 2 1. We need to check the same equation, Ax is equals to lambda x. So just substituting a and x in this equation. So 1k 2 1 into root of 2k 1 is equals to lambda times root of 2k and 1. Trying to solve these two equations, 1 into root 2k will be root 2k plus k will be equals to lambda times root of 2k. So let us name it as equation 1. Coming to the second equation, 2 into root 2k plus 1 is equals to lambda. Let us name it as equation 2. Lambda is equals to 2 into root of 2k plus 1. We will substitute this value of lambda in equation 1 and check whether the equation is satisfied or not. So root of 2k plus k is equals to lambda. In the place of lambda, I will write this value 2 into root 2k plus 1 multiplied by root of 2k. So it will be root of 2k into root of 2k will be 2k. 2k into 2 is 4k plus 1 into root of 2k will be root 2k. In the left hand side, we have root of 2k plus k. So this equation is also not satisfied. Root of 2k plus k is not equals to 4k plus root of 2k. So this is not an eigenvector of given matrix A. So out of 4 options, if we look here, the first option 1 root of 2 by k is a eigenvector of A, and the second option root of 2k minus 1 is not an eigenvector of A, and the third option 1 minus root of 2 by k is an eigenvector of A, and the fourth option root of 2k 1 is not an eigenvector of A. Out of these 4, A and C are the satisfying Ax is equals to lambda x. Hence this A and C, which are 1 root of 2 by k and 1 minus root of 2 by k, these two are the eigenvectors of given matrix A. So the answer is A and C. This is a multiple select question. A and C is the correct answer for this question. We are given a matrix A, we have 4 options. We need to find which of these are eigenvectors of the given matrix. Just with this equation, we have found A and C comes to the eigenvectors of the given matrix A. Coming to the next question. We have R is a set of real numbers and R cube is a 3-dimensional vector space, okay, and we need to find the value for which these set of vectors, we have 3 vectors here, does not form a basis in this 3-dimensional vector space. So what we need to do here is, we need to find the value of alpha such that these 3 vectors does not form a basis in the 3-dimensional vector space. We know that set of vectors to form a basis, the condition is the set of vectors to form a basis, the condition is the set of vectors should be linearly independent. So to does not form a basis means these 3 set of vectors should be not linearly independent. Which means the given set of vectors should be linearly dependent such that we need to find the alpha such that these three set of vectors should form a linearly dependent. So now we know that these three set of vectors are not linearly independent or linearly dependent. So taking the condition of linear dependency, we need to find the value of alpha. So these three vectors are 2 minus 3 alpha, 3 minus 1 3, and the third vector is 1 minus 5 7, 1 minus 5 7. These three vectors are linearly dependent. If these three vectors are linearly dependent, then the matrix formed by these three linearly dependent vectors will be singular, which means that matrix formed by these three vectors, let A be the matrix formed by the given vectors, as they are linearly independent, this matrix will be singular, which means determinant of the matrix formed by these three vectors will be equals to 0. We will use this equation and find the value of alpha. So to find the determinant, 2 minus 3 alpha, which is the first vector, 3 minus 1 3, and the third vector is 1 minus 5 7, and equate it to 0. So finding this equation, so 2 into minus 7 plus 15 minus of minus 3 into 7 minus 1 into 3, which will be 21 minus 3, plus alpha times 3 into minus 5 is 15 minus 15 minus 1 into minus 1, minus of minus 1, equating it to 0. So which will be 2 into 15 minus 7 is 8, 8 into 2 is 16, plus 3 into 21 minus 3 is 18, plus alpha into minus 15 plus 1 is minus 14 is equals to 0. So 16 plus 54 will be 70 is equals to 14 alpha. So the value of alpha is 70 by 14, which is 5. So for the value of alpha is equals to 5, the given set of vectors become linearly dependent, so that they do not form a basis in the given three-dimensional vector space. Coming to the next question, we have a function here. This is a vector function f, which is defined as f1 i cap plus f2 j cap plus f3 k cap, and it is given that the value of the integral of f1 dx plus f2 dy plus f3 dz, which can be written as f cap dot dr cap, which is a line integral of the given vector function. So the value of this integral is same value along any path c starting from a point A to B. So what they want to say here is the value of this integral remains same for any path starting from A to B. So this is point A, this is point B. So if you choose any path starting from A to the point B, let us name it as first path, second path, any path if you take, the value is same along any path. So for what kind of vector function this condition will satisfy? That means if you integrate along any path starting from point A to point B, the value of integral is coming same. So for what kind of vector function we will get such a value? So we know that if for any path, if it is independent of path of selection, then f is an irrotational vector. or we can say conservative vector also. If f is a conservative vector or irrotational vector, then the integral value along any path will be same value. So we came to know that this is an irrotational vector or conservative vector. Now we need to find which of the following options are correct. The only hint we have is f is an irrotational vector. For irrotational vector, we have some conditions. Let us see that what are the conditions we have. If f is a irrotational vector or irrotational vector function or conservative, we can say conservative also. The conditions are curl of f will be equals to 0. We know that if f is a irrotational vector, then the curl of such function will be equals to 0. The second condition we have here is closed path integral of f. So if f is an irrotational function or a conservative function, closed path integral of f will be equals to 0. And also the third condition we have here is f can be written as gradient of some scalar function, where phi is a scalar function. So if f is a irrotational function, these three equations will be satisfied. Curl of f will be equals to 0, closed path integral of f will be equals to 0, and also f can be written as gradient of some scalar function. Coming to the options here, in the first option we have dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is equals to 0, which is nothing but this is a del dot f is equals to 0. If f is a irrotational function, this equation need not be true. This equation need not be true. Coming to the second condition, closed path integral of f is equals to 0 into dr cap. Closed path integral of f is equals to 0. Yes, we have a condition here. If f is a rotational function, then closed path integral of f will be equals to 0. So the second condition is true here. Coming to the third condition, so for this condition we can see here is dou f3 by dou y, dou f2 by dou z, dou f3 by dou x, dou f1 by dou z. Somewhat we are getting a hint that these are some components while for calculating the curl. So what is the definition of curl? So curl of f is defined as determinant of I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, and the third row is f1, f2, f3. So evaluate this value. So I cap into dou f3 by dou y minus dou f2 by dou z minus j cap into dou f3 by dou x minus dou f1 by dou z plus k cap into dou f2 by dou x minus dou f1 by dou y. And the value of this del cross f we have seen here, the value of del cross f will be equals to 0 for a function f which is irrotational. So this value comes to be 0. So if we equate this expression equals to 0, this should go to 0, this term value should also go to 0, and also this term value will also go to 0. So dou f3 by dou y minus dou f2 by dou z will be equals to 0, which means that dou f3 by dou y will be equals to dou f2 by dou z. Similarly, we can write for these two expressions also, dou f3 by dou x will be equals to dou f1 by dou z. This equation can be written as dou f2 by dou x is equals to dou f1 by dou y. So if f is a irrotational function, these three equations should be satisfied. So in the question, f is an irrotational function, so these equations will be satisfied, hence this option is also correct. Coming to the fourth option, there exists a differentiable function f such that f1 is equals to dou f by dou x, f2 is equals to dou f by dou y, and f3 is equals to dou f by dou z. So for this we need to consider this condition, f is equals to gradient of some scalar function. Now in the place of phi we have a function small f here. There exists a differentiable function small f. So let us write this equation. So this equation can be written as dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap. So which is equals to capital F. Now again capital F can be written as f1 I cap plus f2 j cap plus f3 k cap, which is equals to dou f1 by dou x I cap plus dou f by dou y j cap. This is dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap. So if we look at this equation, f1 will be equals to dou f by dou x, f2 is equals to dou f by dou y, and f3 is equals to dou f by dou z, which is nothing but the given the fourth option. So this also is satisfied. So if f is an irrotational function, divergence of f is equals to 0 is not true, closed path integral of f will be equals to 0, so this is satisfied, and these three equations are also satisfied, and these three equations are also satisfied. The correct options are B, C, D for the given question. Coming to the next question, so in this question, rho x comma y comma z comma t is a density, okay, and u of x comma y comma z comma t is a velocity. Okay, we have a density and velocity here respectively at a point x comma y comma z, okay, and a time t. Assume d rho by dt is continuous and let V be an arbitrary space enclosed by surface S. So we have a volume enclosed by some surface. Here S is a closed surface. So S is a closed surface which is enclosing volume V. This is enclosing volume V. So I am taking some random surface, some random closed surface S, and it encloses a volume V. And one more equation we have here, d rho by dt plus divergence of rho u is equals to 0. So we have one more equation, d rho by dt plus divergence of rho u is equals to 0. Now we need to find which of the following equations are equivalent to this equation. So we need to find which of these equations are equivalent to this equation. So we have d rho by dt plus divergence of rho u is equals to 0. So if we carefully look at the options, almost we have same terms here. So we are taking this term to the right hand side, so it becomes d rho by dt is equals to minus divergence of rho u, taking integration on both sides with respect to dv. So integrating on both sides with respect to dv. So integration of d rho by dt dv, v is nothing but the volume enclosed by this closed surface, which will be equals to minus integral over v divergence of rho u into dv. So this is nothing but the third equation, option C. So if we look at this third option, integral over v d rho by dt dv is equals to minus integral v del dot rho u dv, which is nothing but this equation. So option C is correct. We have a Gauss divergence theorem which states that we have a Gauss divergence theorem which states that we have some closed surface S which is enclosing a volume V. The Gauss divergence theorem states that closed surface integral of a vector function A will be equals to volume integral of divergence of the same vector into dv. Closed surface integral of A, which is a vector point function, will be equals to volume integral of divergence of the same vector A. So applying this Gauss divergence theorem for this equation, we will apply the Gauss divergence theorem. Let us rewrite this equation. So we have volume integral of d rho by dt dv, which is equals to minus volume integral of del dot rho u into dv. So this equation divergence of rho u dv can be rewritten as, using the Gauss divergence theorem, it is equals to minus into volume integral is changed to closed surface integral S. So this divergence of A will become A now. So in the place of A we have rho u. So rho u into n cap ds. So by using the Gauss divergence theorem, this equation is reduced to this equation now. Now if we carefully look at the option D here. So if we look at the option D here, which is equal to the obtained equation here. So hence this option is also correct. So for the given density and velocity functions, and also it is said that S is a closed surface enclosing a volume V. Now which of these following equations which are equivalent to the given equation? So we have seen and verified that these two equations are equivalent to the given equation, this given equation. Coming to the next question. So this is a different question based on the differential equation. The complementary function of a differential equation is given. So this is a complementary function. Then the corresponding differential equation is, we need to find the corresponding differential equation whose complementary function is at plus b into e power minus 2t. Now we will go one by one option and check for which differential equation this is the corresponding complementary function. So coming to the first option here, we have d square y by dt square plus 4 dy by dt plus 4 is equals to f of t. This is the given differential equation, second order differential equation. For finding the complementary function, we need not bother about this part, we are only interested in this homogeneous part. So rewriting this term in terms of d's, so it can be written as d square y by 4 into dy plus 4 equating it to 0. For finding the complementary function, we will equate to 0. So we are not bothered about this f of t. So this can be written as d square plus 4d plus 4 into y is equals to 0. So rewriting the auxiliary equation, so m square plus 4m plus 4 is equals to 0. Finding the roots of this equation, which will be equals to m is equals to minus 4 into plus or minus root of 4 square minus 4 into 4 by 2. This term will go to 0. The roots are minus 2 comma minus 2. So the roots of the auxiliary equation are minus 2 and minus 2. So we have a complementary function formula, CF is equals to, when the roots are repeated, we have a complementary function formula C1 plus C2t times e power minus mt, sorry, e power plus mt. So in the place of m we have minus 2, so it is equals to C1 plus C2t e power minus 2t, which is nothing but at plus b e power minus 2t. So this complementary function is equals to the given complementary function. So the corresponding differential equation is option A. So to find the complementary function of a differential equation, we will write it into auxiliary equation, equate it to 0, find the roots, and the formula for complementary function is C1 plus C2 e power mt. In the place of m we have minus 2. So C1 plus C2 t times e power minus 2t. Here just C1 is replaced by b, C2 is replaced by a. So the complementary function is corresponding to this differential equation. So option A is the correct answer for this question. Coming to the next question. So this is a question on probability. So here we have x and y which are independent and identically distributed random variables. Okay, we have x and y which are independent and identically distributed random variables. Both are uniformly distributed in the interval 0 to 1. Now we need to find the probability of x greater than or equals to y. We will try to take x and y on same reference plane. So I am taking random variable x on x axis and the random variable y on y axis. So they will be varying from 0 to 1, and also similarly y will be varying from 0 to 1. So this is the square. So this is the square where x and y will be varying, and we need to find the probability of x greater than or equals to y. Let us find the line which is equals to y is equals to x. Now I will draw the line y is equals to x. So this is the line y is equals to x. Now I have divided the given region into two parts by using the line y is equals to x. Now in this region x will be greater than y. In the shaded region with blue color x will be greater than y, and in this region x will be less than y, or else we can say y will be greater than x. We need to find the probability for x greater than or equals to y. So probability is defined as favorable area by favorable area for this condition by total area. So what is the favorable area for this condition, which is nothing but this blue shaded region? The area of this blue shaded region is, this is a right angle triangle. The area of this right angle triangle is half into base is 1
and height is also, base is 1, height is 1. Whereas total area is area of this square, this entire square, side of square is 1, the area will be 1 into 1, which is equals to half. So the probability of x greater than or equals to y is equals to half. Now we have a next question. This is a question on complex variables and complex functions. We have a function f of z is equals to sin pi z by z square into z minus 2, and c is defined as mod z is equals to 3. Mod z is equals to 3 is nothing but a circle with radius 3 and center 0. So the equation of the circle is mod z is equals to 3, radius is 3 with center 0 comma 0. We need to find the value of closed circle integral of f of z dz. So we need to find the integral of f of z along this path. But we can see here at z is equals to 0 as well as at z is equals to 2, f of z is not defined. We cannot find the value of f of z at z is equals to 0 as well as at z is equals to 2, and these z is equals to 0 and z is equals to 2 are lying inside this circle which is having radius 3. So if I plot z is equals to 0, this is the point z is equals to 0, and if I plot z is equals to 2, it will be somewhere here, so it is z is equals to 2. So these 2 points are lying inside this circle mod z is equals to 3. So now what we will do here is, so we need to find the closed loop integral of f of z, which is sin pi z by z square into z minus 2 dz. Now I will break this integral into multiple parts and apply the Cauchy integral formula to find the value of this integral. Before that, what we have, we will see what is Cauchy's integral formula. So Cauchy's integral formula is closed loop integral of some phi of z by z minus a whole to the power of n plus 1 dz is equals to 2 pi I f phi n times differentiation of a by divided by n factorial. This is the Cauchy's integral formula, where this phi of z is analytical and z is equals to a point lies inside the C. So with the help of Cauchy's integral formula, we will try to find the value of this integral. So I will break this, I will consider 1 by z square by z square into z minus 2 fraction into multiple partial fractions. So it will be 1 by z square into z minus 2 will be equals to a by z plus b by z square plus c by z minus 2. This can be rewritten as 1 is equals to a into z minus 2 plus b into z minus 2 plus c into z square. So to find the each value of a, b, c, we need to take different values of z here. Now in the first case, I will put z is equals to 0. If I put z is equals to 0, this equation will become 1 is equals to, so if I put z is equals to 0, this term goes to 0 and also this term goes to 0. The leftover term will be b into 0 minus 2. So which implies b is equals to minus half. In the second case, I will substitute z is equals to 2 such that this term goes to 0 as well as this term goes to 0. So put z is equals to 2. So it implies 1 is equals to, this term goes to 0 as well as this term goes to 0, c into 2 square. So which implies c is equals to 1 by 4. Now we need to find the value of a. For finding value of a, I will equate to coefficient of z square. So equating coefficient of z square. In the left hand side we have no z square terms. So the coefficient of z square is, in the left hand side we have 0, equating to, if we multiply here it will be z square minus 2z, coefficient of z square is a, here there will be no coefficient of z square, and again coming to this part z square coefficient is c. So it will be a plus c. So a will be equals to minus c. So we have value of c, we can write a is equals to minus 1 by 4. I will back substitute all these a, b, c into this equation. So this sin pi z by z square into z minus 2 can be finally written as, so sin pi z by z square into z minus 2 can be written as, in the place of a we have minus 1 by 4 by z, in the place of b we have minus 1 by 2 by z square, in the place of c we have 1 by 4 divided by z minus 2, and also we need to multiply with sin pi z. So the closed loop integral of this entire function sin pi z by z square into z minus 2 dz will be equals to, so breaking this integral into 3 parts here. So it will be closed loop integral of minus 1 by 4 sin pi z divided by z dz plus closed loop integral of minus 1 by 2 sin pi z divided by z square dz plus closed loop integral of 1 by 4 into sin pi z divided by z minus 2 dz. So if we carefully look at each term, this will be perfect to use the formula of Cauchy's integral formula, so which we have seen here. This is the Cauchy's integral formula where phi of z will be analytic and z is equals to a point lies inside the C. So here we have z is equals to 0 which will be lying inside the C, and again we have z minus 0 whole square which will be lying inside C, and z is equals to point which will be lying inside C, and in the numerator we have minus 1 by 4 sin z, minus 1 by 2 sin z as well as 1 by 4 sin z. So the sine function is analytical everywhere. So these functions will be analytical everywhere. So on each term we will apply the Cauchy's integral formula. So this value will be equals to, we have in the place of a we have 0 here, so which will be equals to 2 pi I times phi of a. So this is phi of z. If I substitute z is equals to 0 here, it will be minus 1 by 4 sine into pi of 0 plus, now we have z minus 0 whole square. So we need to differentiate this term once. So 2 pi I times differentiation of this term will be minus half into cos pi, in the place of z we will directly substitute 0 into pi divided by 1 factorial plus 2 pi I times, now here in the place of a we have 2 here, so it will be 1 by 4 into sine into pi into 2. So this is the value of each term here. Now we will find the value of each term. So it will be sine pi into 0 will be sine 0. So this term goes to 0. and here also sin 2 pi, value is 0, this term goes to 0. The leftover term is this term, which is 2 pi I into minus half into pi into the value of cos 0 is 1. So it will be equals to 2 gets cancelled, minus pi square I. Minus pi square I is the value of the given integral, minus pi square I. So what we did here, we know that z is equals to 0 and z is equals to 2 are the singular points of f of z. That means f of z is not defined at these points. So we have to find the value of this integral. We have broken this integral into 3 parts such that it will be equals to these 3 terms, and on each term we have used the Cauchy's integral formula to find the value of each integral. The final value comes out to be minus pi square into I. Okay. The next session will be taken by Hemant sir. Thank you.
Okay. So next we look at the questions from EMTL subject. So we have, if you also take into consideration the vector calculus portion, we have 6 questions from EMTL. But yeah, as such, core EMTL questions are mainly 4. Okay. So let's look at the next set of questions now. We got 2 questions overall from the transmission lines chapter. So we look at those questions first. Yeah. So this was asked for 2 marks. In fact, this is a very simple question asked for 2 marks. So these kind of questions are actually bonus questions for you. Okay. Okay. So here we have been given a transmission line whose characteristic impedance is given by 50 ohm, and this is terminated by an unknown load. So we don't know the load as such, but we know the magnitude of the reflection coefficient, that is equal to 0.6. And as you're moving away from the generator, we are supposed to find out the maximum input impedance looking towards the load. Okay. So overall in this question we have to find out something known as Z max. And what is the formula for Z max? Z max formula is S times Z naught, where S corresponds to standing wave ratio, and the standing wave ratio is given by S becomes equal to 1 plus mod gamma divided by 1 minus mod gamma. Luckily for us in this question, mod gamma is directly given. Mod gamma is equal to 0.6, 1 plus 0.6 divided by 1 minus 0.6. This becomes equal to 1.6 divided by 0.4, and 1.6 divided by 0.4 is equal to 4. Okay. So substitute this value of 4 here, and also this Z naught is given to you. So substitute both the values. We have 4 into 50 being equal to 200. Okay. So in this case, the maximum value of impedance is seen into the load is nothing but 200 ohms. Okay. So in this case, the answer is 200 ohms. Okay. Yeah. Next question, again from transmission lines. Okay. So this is again a good question, a simple question again. So this question is all about the input impedance of transmission line. Okay. So here in this question we have a transmission line connected to a short circuit. So on this side we have a short circuit, and we are supposed to find out 4 impedances overall. Z in A seen from lambda by 8 distance, Z in B lambda by 8 plus lambda by 8 is lambda by 4 distance, again 3 lambda lambda by 4 plus lambda by 8, I think this will be 1 by 8, 3 lambda by 4 distance, sorry 3 lambda by 8 distance, and then lastly 4 lambda by 8 also equal to lambda by 2 distance. Okay, so this is lambda by 8 and this overall distance is equal to lambda by 4, and this distance corresponds to 3 lambda by 4 and 3 lambda by 8, and lastly total distance here is lambda by 2. Okay, yeah. So first of all we'll write all these distances in terms of angle, right? So whenever length is equal to lambda by 8, so in this case what is the value of beta L? Okay, we are writing everything in terms of angles. Beta we all know is nothing but 2 pi by lambda into length is equal to lambda by 8. So when you do this calculation, lambda is gone, we'll get 2 pi by 8. 2 pi by 8 is pi by 4, which is 45 degrees. Okay. Yeah. So here we have 45 degrees. And rest all distances are multiples of simple integral multiples of 45 degrees. So whenever next case total distance from here to here corresponds to how much? This is lambda by 4 now. So whenever L is equal to lambda by 4, in this case beta L becomes equal to 2 pi by lambda into lambda by 4 becomes equal to 90 degrees. Next L is equal to 3 lambda by 8 third length. So in this case beta L becomes equal to 135 degrees. And in the last case L becomes equal to lambda by 2. So in this case beta L becomes equal to 180 degrees. Okay. So here when seen from lambda by 4 distance, what is the value of input impedance? Okay. So Z in becomes equal to, this is, see for a short circuit transmission line, what is the value of input impedance? The value of input impedance is given by J Z naught tan of beta L. And if you look at the question, you are supposed to find out the normalized load impedance. So when we say that we are supposed to find out the normalized load impedance, so basically we have to find out, so from this small z in becomes equal to z in divided by z naught. When you take that ratio, you will get it as J tan beta L. That's it. So for each of the angle that we have found out, we are supposed to find out the input impedance. So whenever in the first case beta L becomes equal to 45 degrees, then what is the value of Z in? That is J tan 45. J tan 45 is J1. So I can see J1 here for Z in A. And then whenever you take beta L to be equal to 90 degrees, tan 90 is infinity. So then we are having infinity impedance. And Z in C is equal to minus J1. Okay, is it correct? Yes. From now on it's all about cross verification. Okay. So whenever third case 135, tan 135 is nothing but minus 1, we have minus 1 here. And again lastly, whenever you take L to be equal to 180, so tan 180 is 0. Okay, that's it. So we have J1 infinity minus J1 and 0. So hence the correct answer is nothing but A. This was a fairly simple question and this was asked for 1 mark. Okay. Next we have a question from statics portion. That is, yeah. So this is that question from statics portion. This is in fact, if you know the basic meaning of electrostatic field, then the problem is complete. So whenever we say we have electrostatic field, in case of electrostatic field, the curl of electric field becomes 0. Curl of electric field becomes null vector. So if you simply know this point, the problem is complete. You can easily answer this question. So we have been given 2 fields. For both of the fields, we are supposed to calculate the curl. So for the first field, we'll calculate curl. Del bar cross F1 bar becomes equal to dash. So let's calculate. We have x cap, y cap and z cap. And then we have dou by dou x, dou by dou y, dou by dou z. We have y here, x here and 0. So when you calculate the curl for this, curl for the x component of curl is 0, y component of curl anyway will be 0. We'll have only z component of curl. Z component of curl is nothing but dou by dou x of x 1 minus dou by dou y of y, which is again equal to 1, and hence in this case the answer is nothing but 0 bar. So means since f1 curl has become equal to 0, we can say that f1 is electrostatic field. F1 in fact can be electrostatic field. Okay, same kind of discussion we are supposed to do even for the second field. In the second case, we have to calculate the curl of the field f2. Curl of f2 bar becomes equal to, like in the previous case, x cap, y cap, z cap. Take the differentials, write the vector components. We have y and we have minus x 0. So this becomes equal to, again we have to take only the z cap component, because x and y cap components, if you calculate also, they become equal to 0. Z cap component, if you take, dou by dou x of minus x is minus 1 minus dou by dou y of y is 1. Okay, so finally this becomes equal to minus 2 z cap, which is in fact a non-zero value. So since curl of the vector field f2 is non-zero, we can say that f2 is not a electrostatic field. So while f1 is electrostatic, f2 is not electrostatic, and from the options only f1 is electrostatic, but f2 is not electrostatic. Okay, yeah, so this is again a fairly simple question. We have another question, I don't have that question in fact in typed format. I'll write this question. Yeah. So in the last question that you have from electromagnetics, the question is from in fact electromagnetic waves. We have an electromagnetic wave which is propagating into in fact the conducting medium. Okay, so basically the question is all about electromagnetic wave travels from air to conducting medium. Okay, so the expression of electric field in air, that is the instant wave before it hits the conductor, is given by, so this is some magnitude we have E naught, the time component is not given, but the space component is given as e power minus j 2 pi by 3 into x. Okay, and it was told to us that this is a positive x traveling wave. So the conductor boundary is assumed to be equal to x equal to 0. The conductor air boundary is assumed to be x equal to 0. So given this data, finally we are supposed to find out, we have to find out the location of first null of magnetic field. So the point where magnetic field becomes equal to 0, the first point where the magnetic field becomes equal to 0 is what we are supposed to find out. Okay, again this is a logical question, I should say. This is not of much calculation involved. There is no much calculation involved in this question. So let me show you the entire discussion in the form of a diagram. This is entirely conductor medium for us. This is conductor. This is conductor, and this is air medium for us. Okay, and we have one wave traveling towards the conductor medium, and we all know that whenever we have dielectric conductor medium, so the reflection coefficient at the conductor medium is equivalent to -1. Okay, and hence there is another wave which is traveling away from the conductor medium. Okay, so here dielectric conductor interface is equivalent to a transmission line terminated by a short circuit. Okay. So we don't have to do any calculations here. If you simply understand this point, problem is done for you. Why is that so? Because in both cases, since in both cases the reflection coefficient becomes equal to -1. So due to this reason, whenever we are analyzing the electromagnetic wave, when the electromagnetic wave is traveling from dielectric medium into conductor medium, that is equivalent to analyzing a transmission line, assuming that it is terminated by a short circuit. Okay. So from this, now what we can do is we can draw the standing wave pattern. So I am taking this boundary and I am assuming that the boundary is x equal to 0. Towards your right side, x increases. X increases towards your right side, and obviously towards your left side x decreases, right? So now if you notice, I am drawing the standing wave pattern. So we are standing wave pattern. Standing wave pattern for a transmission line terminated by a short circuit. What kind of a standing wave pattern we'll get? We'll get exactly at the boundary location. Exactly at the boundary location, we'll get voltage 0, but current maximum. We get voltage 0, but current maximum, and so on. So the graph that we have shown in pink is the current graph, and the graph that we have shown in white is the voltage graph. So whenever you are converting this into now EM wave analysis, voltages are equivalent to electric field. Voltages are equivalent to electric field, whereas currents are equivalent to magnetic field. So current is equivalent to H, which is magnetic field. Okay. So H being magnetic field. So now you are supposed to find out what is the location of the first null, the location where magnetic field became equal to 0 first. So that is equivalent to the distance between a voltage minima as well as voltage maxima. We all know that distance between a voltage minima and the next voltage maxima corresponds to how much? This distance corresponds to, this is lambda by 4. Okay, that's it. So all you have to find out is nothing but this value, lambda by 4. Okay, so at what location you are having the, at x equal to minus lambda by 4, we have the first H null. H means magnetic field null. That's it. So what is the value of lambda here in the question? So let's look at the given data. So in the given data, we have been given this term. Now we all know that this part of the question corresponds to what? This corresponds to minus j beta x. And from this, what is the value of beta? Beta is 2 pi by 3. And from this, what is the value of lambda? Lambda is equal to 2 pi by beta. So when you substitute the value of beta here, you get the value of lambda to be equal to 3. That's it. So once this part is complete, now you can say that, yeah, at what location you're having this value? Minus 3 by 4, because lambda value is nothing but 3 meters. So at this location, we are having the first magnetic field null. That's it. So the moment you draw this standing wave pattern, now the task is complete for you. Okay. So yeah, these are the questions that you got from EMTL topic. Except this question, this is kind of a bit not so touched question by students, because they gave electric field information and they asked you to calculate the magnetic field information. So a bit tricky. So some people may not notice that the question is about magnetic field, not about electric field. So due to this, there is a possibility of you doing a silly mistake. But yeah, except this, rest all questions are in fact very simple questions we have. Okay. Sure. So this is about the EMTL topic. Next we have the discussion regarding the network and also analog circuits by Gautam sir. Okay.
స్టార్ట్ చేస్తారా? Start, sir. Okay guys, welcome back. So now I'll quickly discuss the questions from analog circuits again in today's GATE EC paper. So on the screen we have the first question. This is actually what a 1 mark question. So what is given in this question? We have a switch which is being closed at t equal to 0, and then we have this resistor of value 10 kilo ohms, and then we have this Z0 diode with a breakdown voltage of 5 volts, and then we also have this capacitor which is initially charged to what, this 10 volts, okay, which is initially charged to 10 volts, and the switch is what, being closed at t equal to 0. The question is what, to find the total energy dissipated by the Z0 diode. Find the total energy dissipated by the Z0 diode for t greater than 0, and you should find it in units of millijoules, okay. So just write it, sorry. Total energy dissipated by the Z0 diode for t greater than 0 is dash millijoules. It is quite simple. Just have to understand what happens for t greater than 0. Okay. So first of all, for t greater than 0, the switch is going to be closed. Okay. The switch is going to be closed. So because the cap is what, initially charged to 10 volts, the Z0 diode will be in reverse breakdown. So the voltage across the Z0 diode will become what, 5 volts, and it remains constant as long as it is in reverse breakdown. Okay. Now the current will obviously flow in the counterclockwise direction because of the voltages, and this current with respect to the capacitor, is it not flowing out of plus? A positive current flowing out of plus means what? That the cap will get discharged. Okay. So let us call this current as I. So this current will discharge the capacitor. Okay. But the question is, till what point the cap will get discharged? Usually when a cap is getting discharged and all that, the cap will try to get discharged to what? 0 volts or get fully discharged, but here that is not the case. So as time progresses, as time increases, the cap will keep getting discharged. So the voltage across the cap, I'll call it VC, it keeps on decreasing. Yes. When VC becomes 5 volts, okay, from 10, as it keeps decreasing, at some point VC becomes 5. Now this side is 5, this is also 5. Then the current in the circuit will become what? 0. If the current becomes 0, then there is no more discharging for the capacitor. Okay. So in this way, VC at steady state, it is what? 5 volts. Unlike the usual cases where the steady state value of VC will be 0, but here it is what? 5 volts. Okay. So after that, what happens? No current. That's all. Even the Zener diode will be kind of off and no current will flow. So VC is going to decrease from 10 to 5. Okay. And in this process, what is the total energy dissipated by the Zener diode? That is the question. Okay. What is the power dissipated by the Zener diode? It is voltage times the current flowing into plus. So it is what? Vz times I. Vz is what? Constant. So is it not 5 times I? And if you want to find energy, just have to integrate the power. Okay. So E Z is what? Integration of Pz from 0 to infinity. Now in place of Pz, you can write 5 times I. 5 being constant will come out of the integral. So 5 times integral I dt from 0 to infinity. So what 99% of the people will be doing is to write the expression for I. Yes, is to write the expression for I and then try to integrate that I from 0 to infinity. But there is a more elegant way to go about this calculation. What is this current doing? Is it not discharging the capacitor? Yes. And you know, for a capacitor, we have I equal to what? C dV by dt. This is a familiar thing. Okay. But what is current? Rate of flow of charge. Okay. Integral I dt is actually what? Change in charge. Change in charge for the capacitor. So what is VC initial? It is 10 volts. What is the initial charge stored in the capacitor? It is, I think the value of the capacitance is missing. Oh, it is 10 microfarad. So the capacitance is what? 10 microfarad. So what is the initial charge stored in the capacitor? It is the initial voltage times the capacitance, which is 10 microfarad into 10 volts, and this is like 100 microcoulombs. Okay. And then what is VC final? What is VC final? Finally, the cap will discharge to what? 5 volts. Okay. Thereafter, there is no discharging and all that. So what is Q final? It is half of this. Okay. In fact, 10 microfarad into 5 volts, which is like 50 microcoulombs. So initially, the charge stored in the cap is what? 100 microcoulombs. And at steady state, the charge stored in the cap is only 50 microcoulombs. So what is the amount of charge that is taken out of the capacitor? It is 50 microcoulombs. So straight away I can say integral I dt from 0 to infinity is equal to what? The change in charge. In this case, you can say mod delta Q magnitude, and it is what, 50 microcoulombs, which is also same as 50 times 10 to the minus 6. Now you come back to this total energy dissipated by the Zener diode in this discharging process. Okay. So in place of this, we have to write 50 microcoulombs, which is 50 into 10 power minus 6, which is 250 into 10 power minus 6. We have been asked to find the value in millijoules. So this is what, 0.25 millijoules. Okay. So this is also one way to do it. So you don't have to write the expression for I. Okay. All right, guys, there is the next question from analog circuits. This again, I believe it is what, a 1 mark question. So here it is what, a full wave rectifier. Yes, so just by looking at the circuit, you should be able to tell that it is what, a full wave rectifier, and this thing is what, a step down transformer. Yes. And then we have this diode D1 and also diode D2. What is given about the two diodes? That both are ideal. So meaning the on voltage, it is what, 0. Okay. And what is this Vs of t? The input voltage applied on the primary side, it is 10 sin omega t volts. Yes. And if the average value of the load voltage, that is voltage across RL, is what, 2.5 by pi, then the question is, what is the value of N? Yes, N is to 1 is what? The turns ratio of the step down transformer. Okay. So this is what, a center tapped transformer. So this is Vp sin omega t. This is also what, Vp sin omega t. Okay. So VL peak value is what, Vp, and VL average is what, 2 Vp by pi, and this average value is what, given as 2.5 by pi. 2.5 by pi. So now this pi and pi will get cancelled out, and then Vp is what, 2.5 by 2. Vp is what, 2.5 by 2. Now this is actually what, a center tapped transformer. See, for a center tapped transformer, generally in analog circuits context, the turns ratio is what, the ratio of the number of turns on each half of primary to the number of turns on, ratio of number of turns on primary to the number of turns on each half of secondary. Sir, secondary ఇప్పుడు ఇది ఉంది కదా, సెంటర్ ట్యాప్ ట్రాన్స్ఫార్మర్, దీనికి టర్న్స్ రేషియో డైరెక్ట్గా ఇది N1 నెంబర్ ఆఫ్ టర్న్స్ ఆన్ ప్రైమరీ, ఇట్ సైడ్ ఈచ్ 1 టోటల్ జనరల్గా ఈచ్ హాఫ్ అనే చెప్తాం. ఓకే, ఎనీవే so what is the peak value on the primary side? It is 10. What is the peak value on each half of the secondary side? It is 2.5 by 2, and this ratio is generally what, the turns ratio of a center tapped transformer. Okay, because earlier also in many questions from ESC exam, this turns ratio for center tap transformer is what? Ratio of number of turns on primary to the number of turns on each half of secondary. Anyway, we just have to verify from the most accurate source. Okay. So that's all. So 10 by 2.5 is what? 4. 4 times 2 is what? 8. So n equal to what? 8. Yes. All right, guys, look at the next question. This is what a 2-marker. This is a 2-mark question. In fact, it is what? An RC phase shift oscillator. It is similar to what? The Weightage oscillator, but it is not exactly a Weightage oscillator. And the question goes like this: for sustained oscillations R1, what is R1 in terms of R? So is it like 2R or 3R or 4R or yes? So R1, what is it in terms of R? And also what is the frequency of oscillation? So after all, it is what? An oscillator. So the frequency of oscillations F0, you have to find it in the units of hertz. Okay. So how do you go about this analysis? You have to break the loop and then apply a signal Vt and then find the loop gain and then use the Barkhausen condition, which is that the imaginary part of loop gain is what? 0, and that the remaining real part must be equal to what? 1. So generally in these circuits, we break the loop here and here we inject a signal Vt, and this Vt will go around the circuit and come back at this point. So we call this V return. Okay, so you have to find V return by Vt. Well, before that, we have to make one simple observation. Just look at only this part of the circuit. Yes, when you break the loop here, still the op amp will be in negative feedback. Yes, and this Vt is like the input applied at the plus input terminal, and this R1 and R complete what? The negative feedback. So in fact, it is what? The non-inverting amplifier. So this green color part of the circuit alone forms what? A non-inverting amplifier. So what is the output or what is the gain of a non-inverting amplifier? 1 plus R1 by R. So what is the signal here? 1 plus R1 by R times Vt. 1 plus R1 by R times Vt. Okay. And then if this is V return, this is also what? V return. So now you have to do the analysis for this feedback network. Okay, CR. So first you have what? A CR section, which is like a phase lead network, followed by an RC section, which is what? A phase lag network. Okay, so this will provide a positive phase shift, this will provide a negative phase shift. At some frequency, the two phase shifts will exactly cancel out each other, resulting in a net phase shift of 0 degrees, so that the overall phase shift around the circuit will also be 0 degrees. This is the principle of this circuit. So one provides positive phase shift, another subnetwork will provide negative phase shift. Okay. By the way, this current is what? 0. So because this current is 0, even this current is 0, which means this R and this C are going to be in series. Okay. And let's assume the voltage at this point to be some Vx. Okay. So what is V return in terms of Vx? So for this R and C combination, we can use voltage division because these two are in series. Okay. So V return, that is the voltage here, which is same as what? The drop across this capacitance in terms of Vx will be what? Vx times Vx times 1 by SC upon R plus 1 by SC, which can be written as Vx upon 1 plus SCR. That is what we written. And now what? You have to write KCL at this node. So you can write this current, you can write this current, you can also write this current, okay. So at this node, this current is entering, these two currents are leaving. So what is this current to start with? So Vt into 1 plus R by R1 minus Vx upon 1 by SC is equal to what? Vx by R, and also this current is what? Vx upon R plus 1 by SC. Vx upon R plus 1 by SC, okay. So let us try to simplify this. So SC times Vt times 1 plus R by R1 minus SC Vx is equal to what? Vx by R plus SC Vx upon 1 plus SCR. So SC Vt times 1 plus R by R1 is equal to what? SC plus 1 by R plus SC upon 1 plus SCR times Vx, okay. So SC Vt times 1 plus R by R1. So if you take LCM and so on, I think the LCM is what? R times 1 plus SCR. So SCR plus S square C square R square plus again 1 plus SCR plus SCR whole divided by 1 plus SCR, this whole thing multiplied with Vx. Remember, Vx is what? V return times 1 plus SCR. I hope you are following this. So in place of this Vx, we can write from this equation V return times 1 plus SCR. So when you do that, where you write V return times 1 plus SCR in place of Vx, that 1 plus SCR and this 1 plus SCR will get cancelled. So I'll just cancel this out, cancel this thing as well, and directly write V return. That's all. So what is V return by Vt? What is V return by Vt? I think it is, did we miss anything? So the LCM also has R, because right hand side the LCM is what? R times 1 plus SCR, okay, and this R will go to this side. So SCR times 1 plus R by R1 upon S square C square R square plus 1 plus 3 SCR. Now what? You have to substitute. So what is this V return by Vt? That is nothing but the loop gain. Now you have to substitute S equal to j omega and then apply the Barkhausen condition, yes, which tells us that the loop gain must be purely real and also equal to 1, okay. So in place of S, when you substitute, S equal to j omega, this becomes what? J omega CR. S square is what? Minus omega square. So 1 minus omega square C square R square plus 3 j omega CR. Yes, and then you divide both numerator and denominator by j. Then numerator becomes what? Simply omega CR times 1 plus R by R1. Denominator will be what? Omega CR times 1 plus R by R1 upon 3 omega CR plus I mean 1 by j is what, like minus j. I think this is minus j times 1 minus omega square c square r square. This is the final expression for the loop gain. Now the loop gain must be what, purely imaginary, I mean sorry, purely real. Okay, so already numerator is what, purely real. Now for the overall fraction to be purely real, even denominator must be what, purely real, for which the imaginary part of denominator must become 0. That means 1 minus omega square c square r square must be 0, and from there you will get omega equal to what, 1 by rc. So from here we get so from here we get, sorry, omega naught equal to what, 1 by rc, or f naught in terms of Hertz will be what, 1 by 2 pi rc. Now the other thing is what, once you make this thing 0, what is left? Omega cr will get cancelled out, then only 3 will remain in the denominator, 1 plus r by r1 divided by 3, and that must be equal to what, 1, and from there you will get r equal to what, 2 r1. So what is the original question? Yes, okay, it is 1 plus r1 by r, I'm sorry, it is 1 plus r1 by r. So here I made a small mistake. So it should have been r1 by r. So throughout this analysis, it is not r by r1, it is r1 by r. So anyway, the fact of the matter is what, r1 equal to what, 2r, and f naught is what, 1 by 2 pi rc. So this non-inverting amplifier should have a gain of what, 3, and the feedback network will have a gain of 1 by 3 at the frequency of oscillation. This is the idea behind this circuit. Okay. Actually, we are running out of time. Still, we have to discuss a couple of questions, because 8:30 we have to start electrical session. So what I will try to do, so all right guys, thank you for being a part of this session. Still we have to discuss signals and systems and also communication. So ఒకసారి వినోద్కి కాల్ చేసి So what I'll do is I'll quickly run you through all the questions from signals and systems and also communications. Okay. So MY sir is not available with us right now, but we have sent him all the questions and he sent us the answers. So in a later session, he will discuss all the questions. Okay. But for now, we'll only present the answers. Okay. So this is the first signals and systems question, and the answer is what? This 2y of 0.5 t. And second question is what? This one. There is some discrete LTI system for which the transfer function is given, and then you have to select the correct options. The correct options are, so the correct options are A, C and D. Okay. And then we have this question where some signal is given and it is said that it is sampled at so and so frequency, and then it is applied as an input to some LTI system. For that LTI system, the impulse response is given, and then you have been asked to find the resulting output. The answer is what? This. Okay. So the options, we don't have them, but the answer is what? This. Again, this is what? An MSQ type of question. So radian frequency values for which the discrete time sinusoid has a period of 40. So the correct options are A and C, 0.45 pi and 0.15 pi. Okay. So there are two signals here which are similar except for some inversion and also delay and also some expansion or compression. So this is x of t, this is what? Y of t, and for x of t the Fourier transform is capital X of f, and for this it is what? Capital Y of f. So what is the relation between the two Fourier transforms? Okay. So the correct option is what? Option C, minus 4 x of 4f times this. And then we have a question on DFT. So it is a sequence on which the endpoint DFT is performed, and the resulting result is what? This x of k. And then if you form a new sequence which is this, the question is what? To find y of 0. Yes, and the answer is what? 16. Moving on to communications. So a source is given, it transmits symbols from an alphabet of size 16. The maximum achievable entropy is how many bits? It is what? 4 bits. Okay. And then we have some noise with 0 mean and power spectral density of N0 by 2. And this noise signal is passed through a first order low pass filter, that is what? An RC filter, and the resulting output is what? N of t. And from this we form a random variable N of tk, and for that random variable what is the variance? The answer is what? D, N0 by 4 RC. Next question, the output of an amplitude modulator is given. There are 3 components here. The carrier power normalized to what? 1 ohm resistance is what? 50 watts. You have to find this ratio. Ratio of the total sideband power to the total power is what? 1 by 9. Then what is the value of B? Yes, and the answer is what? 2.5. An information bit sequence is to be transmitted using CRC encoding, and the generator polynomial is given. Okay, x power 4 plus x plus 1. And then the encoded bit sequence is what? This. Okay. I think extra you are getting 4 bits which are 1 1 and then 0 0. Okay. And then we have this question, x of t is what? Random process. You have to find SQNR in is how many dBs. The answer is what? 45.15. Okay. I think this is the last question. A source transmits a symbol S. So from these you pick one of these, and then you transmit it over a additive white Gaussian noise channel. And at the receiver you get this, okay, the actual symbol along with noise. Okay. And then Q of x is what? This thing. The optimum symbol error probability is what? This. I think you have to just find the threshold, and from there you can get the answer. Okay. So the answer is what? A, 4 by 3 times Q of 1. So we'll just close the session for now. So tomorrow we'll discuss whatever remaining questions are there. Thank you for attending and wish you all the best. Okay.